Good morning, everyone. A very good morning to each and everyone. I hope you people are doing good in your respective homes. So day by day, the corona cases was increasing, and apart from that, we have been seeing from the past 2 days the effect of the cyclone in West Bengal. So the people who are staying there, be safe. Good morning to everyone. Now, so today we are going to see a new board. Instead of whiteboard, I'm going to take as a blackboard. Actually, you were getting some problems. So regarding to the yes. So I'm showing you a new type of board over here. And in this board, you are going to see at the bottom what I'm showing over here. I hope everybody is able to see this one. 1F, 2F, 3F, 4F, 5F, and these are the page numbers. These are the page numbers, and it will be very easy accessible for us to swipe from one page to the other page. So whenever you have a doubt, you can you can say to me, sir, go to the 5F or 6F. So this is the page numbers. The F represents the page numbers, and as we have been experienced a lot of lagging yesterday, so I'm going to this board today. Let's see how it is going to be useful for us today, and if it is going to be comfortable for everyone, then we can now see the remaining things also. Sorry, it's the end to the world. No, it's not the end to the world. Yes, today we are going to start shear strength also. Sir, I want to give gate before dying. You don't need to worry about die, so you can live. Don't worry about that. Okay, fine. Yeah. So now let's see. So yesterday I have given you, means I asked you to solve the compaction 2 questions. So this is from the compaction chapter only, and now from compaction chapter. Okay. So you see, this is question number 1, and mind it, this was a gate. This was GATE 2006 question. This was GATE 2006 question, the same question that has been appeared in GATE 2006 question model. Same type of the model has been appeared in GATE 2006. Now, the compaction of an embankment is carried out in 300 mm thick lift. The compaction of an embankment is carried out in 300 mm thick lift, which means the thickness of a lift. Thickness of lift is 300 mm, which means 0.3 meters, and the foot area is going to be 0.05 meter square. So whatever the compactor you take, that lift, the thickness of the compactor is going to be 400 means 300 mm as 0.3 meter, and it's a foot area. You know that This is our compactor. This is compactor, and you see the thickness is going to be 0.3 meters and the foot area is going to be 0.05 meter square. So now, yes, this is a CRPQ only. This is classroom practice question. So classroom practice question, question number 1. This is the same model of the GATE 2006. So, but here is classroom practice question, question number 1. Now, the energy developed per drop is going to be 40 kg meter. Energy developed per drop is going to be 40 kg meter. Assuming 50% more energy is in each pass over the compacted area due to overlap. So now, due to overlap, the net energy developed is equals to 50% more. 1.5 into 50, which is going to be 60 kg meter. See, I am just writing the data. That's it. I am just writing the data. So first I am taking the thickness of lift and foot area and energy developed, and due to overlap, the net energy developed is going to be 50% more than the 50% more than the given energy. So the number of passes required for each layer. How many number of passes required for each layer to develop compaction energy? To develop the compaction energy equivalent to IS light compaction. So now can you please tell me, from IS light compaction, compactive effort. Yesterday I have discussed with the compactive effort. I hope you remember those compactive efforts. So from IS light compaction, I hope you remember these values. Yeah. So yesterday we have been discussed about for standard Proctor test how to find out the means compaction effort. The similarly in the case of the IS lightweight, you know the remaining details, right? So using these details you can find out. So this is IS lightweight test. The details are going to be 2.495 kg, 304.8 mm, 944 cc, and 3 and 25. So now let's. So now let's see in the case of the IS lightweight compaction, now observe how many number of layers we are going to use? 3. How many number of blows? 25. What about the weight? 2.495 into what is the height? 304.8 mm, which means 0.3048. This is going to be kg meter per unit volume. What is the volume I have given? 944 cc. Cc means 10 to the power of 6 meter cube. So now from the IS light compaction, can you please tell me what is the total compactive effort? Compactive effort. See, what is the meaning of compactive effort over here means? What is the meaning of compactive effort over here? So 3 into 25 into 2.495 into 0.3048 by 944 into 10 to the power of 6. So if you solve, this is going to be 60,419.17 kg meter per meter cube. Kg meter per meter cube. See, this is going to be almost similar to the standard Proctor test, right? But the given is IS lightweight test. Yesterday I told you the IS lightweight is almost similar to the standard Proctor test. So now just have a look over the previous yesterday's values also. If you look over the yesterday value, what is the value I got for standard Proctor test? 60,450. Now what I got over here is going to be 60,419, just a 30 less. That's it, right? So this is from the IS light compaction. Now what they're asking is the number of passes required for each layer to develop the compactive energy equivalent to IS lightweight. So if I use this compactor, then what is the net energy developed? 60 kg per meter. And what is the energy, compactive energy effort is equals to 60 by what is the volume? You need to find out in terms of volume, right? What is the units over here? Kg meter per meter cube. So now what is the volume over here? Area 0.05 into 0.3. So now can you please tell me this value? 60 by 0.05 into 0.3, which is going to be 4,000 kg meter per meter cube. See, this is by using the by using a compaction of embankment, the rammer, whatever the rammer. So this is the compactive effort of a rammer. So rammer compactive effort is going to be how much? 4,000. Now I know the compactive effort in the case of the IS lightweight compaction, 60,497.17. Now the question is, in order to attain the IS light compaction, how many number of passes are going to be required in the case of the rammer? See, for one blow, it is going to be 4,000 kg meter per meter cube. So now the total number of passes into rammer effort is equals to IS light compaction effort. So now with this I can write the N into what is the rammer effort? 4,000 is equals to 60,419.17. From this, can you please find out the N value? 60,419.17 by answer, which is going to be 15.10, and nearest value is going to be 16. So what is the nearest answer? Nearest answer is going to be 16. So now you please observe what I have done is I take the IS light compaction test and I got the total energy imparted in terms per meter cube is going to be this one. Yes, per meter cube. And in the case of the rammer I used per meter cube. See, what is the energy I imported due to overlapping 60? Per meter cube, how much? 4,000 kg per meter cube. So now, in order to impart this IS light compaction energy, how many number of blows? Likewise, per blow 4,000. Likewise, how many number of blows you have to give? 16 blows you have to give. So now, this same type of model have been given in GATE 2006. You please go to the GATE 2006 and you solve on it on your own. Sir, if there's an option of 15, what should we choose? If there's an option of 15, you have to choose 16 only. You have to choose 16 only, because always we go for the higher side. We are an engineers, right? When we go for engineers, means in order to attain more compaction, we go for the higher side. This rammer effort, rammer means, see, this is going to be net energy developed, right? So which is going to be net energy per unit volume. net energy per unit volume. So you know that how to find out this Ramer effect. So how to find out the Ramer effect? Will you please tell me how to find out the Ramer effect? So the Ramer effect is nothing but number of layers into number of blows into weight into height of fall by total volume. See, this is nothing but the net energy, right? Net energy per unit volume. That's it. It's just based upon the options, sir. So they won't give you that in ambiguity. So they won't give you 15 and 16 also. If they give, that's a fool person, or else he has copied the question somewhere. So if the person is going to be able to think and give the question, then he won't give you the nearest value to the 15 also. So in options, they won't be 15 and 16. Now, see, this is a foot area and this is thickness. Then what is the total volume of the thicker? That much volume is going to be compact also. This is mold and this is going to be Ramer, whatever the Ramer I'm using. For that only I'm finding all of these things. So Ramer energy effort is going to be 4000 and net is going to be whatever the total effort is equals to IS light compaction. That's what I said. Number of passes required for each layer. This is for one layer, right? To develop compact energy equivalent to IS light compaction. So how many number of blows I have to give by the Ramer to get IS light compaction? That's about the question number 1. This is a classroom practice question, question number 1. So next, coming to the question number 2. Whatever. Now, see the in situ. What is the meaning of granular deposit? Granular means cohesionless soil. Granular deposit means cohesionless soil. Okay. So now, if you observe, the in situ means void ratio. In situ means field. So you know the meaning of in situ, right? You know the meaning of in situ. In situ means field. Okay. So now, in the case of the in situ, void ratio is going to be 0.5. Maximum E max is equals to 0.75 and E minimum is equals to 0.35. And apart from that, I have given you G value as a 2.67. The relative compaction. The relative compaction. You know the relative compaction means gamma D of field by gamma D of maximum into 100. Gamma D of field by gamma D of maximum into 100. See, somebody asking, sir, what is this 50%, sir? See, due to this overlapping, how much energy is going to be increased? 50%. So due to overlap, 50% energy increase. So the net energy is going to be 1.5. Initially 140. Now it is going to be increased by 50%. So now I told you yesterday, if it is a gamma D of field, then I can write it as 1 plus E minimum by 1 plus E into 100 also. So 1 plus E minimum 0.35 by 1 plus E maximum. What is going to be, sorry, what is the E value? 0.5 into 100. You don't need to go for C. Sir, I don't want to remember this equation, sir. Fine. If you don't want to remember this equation also, you can get it done. How, sir? Gamma D is nothing but G gamma W by 1 plus E, sir. So there is E and there is G. You can find out gamma D. And there is a E minimum and there is G. You can find out gamma D maximum. So with this, you're going to get exactly 90%. So the answer is going to be 89.9%. Now, some of the people are saying, sir, if we use relative compaction is equals to 80 plus 0.2 times of ID. See, this is an empirical relation. This is an empirical relation. Sir, when to use this empirical relation, sir? This is an empirical relation, and if they don't give the wide ratios and if they give you the ID value directly in question, if ID is mentioned directly, without void ratios, then use above relation to find a relative compaction. So, see, if they don't give you the Emax or E minimum or E value, if they give you directly the relative density, means relative density ID value, then you can use this one. This is an empirical relation, and this is the actual relation. So you don't need to worry about the empirical relation or actual relation. Actually, this empirical relation is going to be state whether the soil is going to be highly compacted or not. So now I want to introduce one more point. If the relative compaction is more than 90%, if the relative compaction is going to be more than or equals to 90%, it is going to be well compacted and in permissible limit. So what is the meaning of this relative compaction is 90% over here? Can you please tell me? Can you please explain what is the meaning of relative compaction 90% over here? The relative compaction of 90% is compared to, observe, compared to maximum, I attained a 90% denseness in the field. See, if you can get more than 90%, then it is going to be well compacted and it is in permissible limit. So this equation, I hope some of the people have used this equation. Arey Baba, why to go for that much? Think about that. If you want to find ID is equals to Emax minus E by Emax minus E minimum into 100. Okay. So if you find out the ID value and if you go for the relative compaction, then it is going to be 92.5%. I'm telling you, this is an empirical relation. And in this equation, in question, if ID is mentioned directly without void ratios, then use above relation to find out the relative compaction. Sir, why then they give Emax? It's up to them, Ray. I am a person who frames the question. It's up to me. I will try to confuse you. No, it won't be same. If you use this relation, you will get it as 92.5%. We don't use we don't use C. The relative value means if it is 90%, you cannot take it as 94.3%. Yes, 90 to 95% is going to be permissible limit. More than 90% is going to be well compacted in permissible limit. Sir, is it necessary to use all the data of question in the gate? No, you don't need to use all the data in the question. Whatever the data you require. See, I have done it within a single step, right? I done it within a single step. I got the value, right? So I don't need to go for the whatever required. What is the relative compaction? The dry density in the field to the maximum dry density. Yes. What is the maximum dry density? When the void ratio is going to be minimum. 1 plus E minimum by 1 plus E into 100. I don't need to worry about the maximum void ratio. So do not use this relation directly. Please, I am telling you, don't use this relation directly. This is just for the sake of relation between the relative compaction and relative density. And if they give ID value directly, then only you use the relative compaction, please. That's it. If we get 92.5%, which option should we choose, sir? You please, sir, I just said you, sir, relative compaction is the, if you use this formula 92.5, that's not correct. Why E minimum, why not E maximum? Go to hell, Ray. How many times I say? When density increases, what happens to wide ratio? कहाँ है आपका दिमाग? कहाँ है? Sir, can you repeat once? Why, my dear? Just now you came. It's already there. It's already there. And for this question also, I have taken a lot of time to explain to you. See, this is a basic question, and I told you everything over here. This is an empirical relation. So whenever the ID given without wide ratios, then only use this above relation. Else, this is the actual relation. So you use the actual relation only, not the empirical relation. Sorry, is tomorrow a holiday? Is tomorrow a holiday? Hardly we started today, and you want tomorrow a holiday. Okay, fine. Now, this is a GATE 2004 question. GATE 2004 question. So you please go over this question now. Yeah. A clay soil has a maximum dry density. What is gamma D max? 16 kilonewton per meter cube. And optimum moisture content OMC is given as a 12%. A contractor during the construction means during construction, which means in field, the gamma D we attained is 15.2 kilonewton per meter cube and water content is 11%. This construction is acceptable because the question is, they are saying the construction is going to be acceptable. You see, in the laboratory, when we solved, this is the gamma D max we got, this is the OMC we got. But during the field, whatever the dry unit weight we got is 15.2, and what is the water content? 11%. So, and still this is going to be acceptable. Why? Now, just now I mentioned you, whenever the relative compaction, somebody asked me what is the purpose of relative compaction, sir? Sir, if the relative compaction is going to be more than or equals to 90%, sir, that is permissible and that is acceptable. So in order to check whether the compaction we attained is going to be good or not, we need to know that the relative compaction should be more than or equals to 90%. Now let's see what is the relative compaction. What is relative compaction? Gamma D in field to gamma D of max into 100. What is gamma D of field? 15 point. See, they're asking acceptable, right? That's the reason why. 15.2 by 16 into 100. 15.2 by 16 into 100, which is going to be 95%. So, which is going to be 95%, which means as relative compaction is going to be more than 90%. This is going to be more than 90%. Then this construction is acceptable. Then the construction is acceptable. See, I told you yesterday, you cannot achieve exactly what you achieved in the laboratory. Why, sir? Sir, in laboratory, how much soil mass you take, sir? Small amount of the soil mass. And you are going to compact there itself, and the efficiency you get is more. But in the case of field, you have to compact large area. And when you're compacting the large area, and if there is any problem in the human errors, you will definitely get a density less than, and if you do completely full, then equals to the gamma D max. So mostly you get less than gamma D max. That is the reason why, as relative compaction is going to be more than or equals to 90%, construction is going to be acceptable because there is a permissible limit. So with this, what is the option over here? You see, The density is less than maximum dry density and water content is on the dry side. The density is less than maximum dry density, I can see. But is it going to be under acceptable limit or not? Compaction density is very low and water content is less than 12%. See, comparatively A and B both are same only. Compaction is done on the dry side of the optimum. Yes, that is a dry side of the optimum, that we know. Just because you compact on dry side of optimum, that is not going to be acceptable. The acceptable is both the dry density and the water content are in the compressible soil are within the desirable limits. That will be known if the relative compaction is going to be more than or equals to 90% and the construction is going to be acceptable. Give me a minute, I'll bring water. Yes. Okay, now, so that's it about the condition. Sir, how to determine gamma dr field by sand replacement methods? No, there are some other methods like sand balloon method. So you don't need to worry about those methods, vibro-flotation technique. That's not in the context and topic also. So you don't need to worry about that. This is gate question, it's not CRPQ. Yeah, nuclear density gate is there, sand balloon method is there. So some other methods are there. You don't need to worry about those methods. Sir, but core of the dam should be constructed on wet side of optimum. Arey Baba, I did not set you directly. I told you if you want to reduce the swelling, you compact on wet side. If you want to improve the strength, you compact on the dry side. See, they said that they did not say see in this dam, they did not say whether I want to compact to reduce the swelling or something like that. So for that, you have to go for the relative compaction. If you see this relative compaction, if the relative compaction is going to be more than or equals to 90%, then the construction is acceptable. Feedback link is not responding. No, it is there on feedback link. And again, I'm asking you people. So those who have not, those who have left over yesterday's class. So you please open your mails and there will be a feedback link that has been sent to you. So you please give that feedback for the class. Not responding, but they said that, yeah, okay, fine. I let them to know that. Vibrofluoridation means by using vibration technique we are going to compact. So first we have to log in, then only it will be respond. So you see, first you log in with your details, then it will be responded. So you please look over that. Today up to 4 p.m. Link is open, so you can give a response. Sir, will you let us know up to what point this online class are going to be continued? Up to what point means it's up to the point when the institutions are going to be open, because as of now nobody knows and everybody is trying their level best to try to reopen all those things. But you know that after all, India is about politics, right? So whenever they want to open and feedback link is also sent to register mobile number, right? And some of the students saying it is working in the through mobile number. You please go through that. Okay, fine. So now let's come to the last gate question. Say I have explained you the classroom practice questions and now the gate question over here. A soil has a specific gravity of its solids equals to G value as a 2.65. Specific gravity of solids, G value 2.65. The mass density of water is 1000 kg per meter cube, which means density of water 1000 kg per meter cube. Considering zero air voids, what is the meaning of considering zero air voids? Na is equals to 0. So considering zero air voids means Na is equals to 0. And 10% water content, the dry density of the soil. You know that dry density means 1 minus Na into G gamma W by 1 plus W into G. This simple one, right? Simply just Na is equals to 0. Then what is gamma D? G gamma W by 1 plus W into G. So G value 2.65 into 1000 by 1 plus 0.1 into 2.65. So you please find it out. 2.65 into 1000 by 1.265. So 2094.861 kg per meter cube. And they're asking round off to 1 decimal. 1 decimal means 2094.9 kg per meter cube. 1 decimal, 86 na. As a second decimal is going to be more than 5, then you can take it as 9. So 2094.9 kg per meter cube. So this is the previous gate question, gate 2019 in set 1. They have asked a question regarding to this. Actually, this type of, see this formula I have mentioned you in chapter number 2. Gamma D is equals to 1 minus Na into G gamma W by 1 plus W into G. If you want, you please go through the previous. Okay, so if you have any doubts regarding to the previous questions, I will be seeing in the doubt clearing section, not now. Mass density क्या है sir? Mass density or weight density, sir. You can take the units, sir. You take units, that's it. You don't need to worry about the other things. Okay, fine. That's all about the compaction chapter. So you please go through this one. So now let's come to the new chapter. Stop your all the things and after completion of this subject, please better not to keep the important subject which has more weightage of gauge through online classes. Why, mister? Why you are feeling like that? Okay, fine. Offline classes are far better when compared to online classes because due to lack of hard copy of material, we are unable to practice in mobile. Please try to send materials in courier as soon as possible. The only advantage of online classes videos can be referred more number of times. Mr. Maruti Raj, nothing is going to be habituated with one time. Nothing is going to be habituated with one time. I'm telling you, I mean, I'm saying this answer to each and everyone who wants to do offline classes also. Yes, I'm a person who strongly allows and who strongly believes offline classes are going to be more attentive than the online classes. But when these type of situations are going to become, we have to adapt the situations. You know what? Everybody knows Darwin, who has given the theory of evolution. He has said one famous quotation: "It's not about the stronger one who survive. It's about the one who adapt every situation will survive." So not all the times the stronger ones are going to be survive. If you're stronger, that doesn't need to be you're going to be survive everywhere. But if you're a person who can adapt every situation into your life, then you're going to be survive anytime. So as of now, though it is going to be new. You see, it is a new for me also. It's not old for me because so previously I did not discuss the online classes. So this is the first time. And compared to the first lecture and today, whatever the 25th day, the lecture, the difference you can see. At first, what we started and now also means I'm saying you the utilization of the whiteboard and these questions and all those things. So you need to adapt these things because we know this is going to be our regular. We know this is going to be our normal. So I'm asking you people, I know it will be a bit difficult for you to cope up with the classes, means compared to the offline, but as of now, the situation, you please focus. And now you don't need to go anywhere. You don't need to take a stress to go to the classroom. You don't need to take a stress to take a seat in the front bench or the back bench. You don't need to stress out yourself by looking over all the people surrounding by you. You can sit in your home in a comfortable position and you can take your laptop or mobile and you can see the videos in number of times. So I hope everybody have been habituated with the mobiles, right? How many years back the mobiles have been invented? Does the mobiles has been invented some 1,000 years back? No, right? Hardly from 2000. And at the end of the 1990s, some mobile phones has came. And how we have been habituated from the past 15 to 20 years. The 2 decades of the mobile phones is ruling 2000 years of human life now. Each and every individual is having a mobile phone. So how you have been or how you have been habituated with some other games, or how you have been habituated with the Facebook or Insta and WhatsApp and all those things. If somebody is going to be messaging you and if somebody is going to be calling you, you have been habituated to chats or messages for hours and hours, right? The same way, this is a new thing that you need to adapt. Now, if you want to be stronger, then you have to adapt to each and every situation. Sorry, sir, everyone won't have the same situations. Yes, I know that. Yes, everyone won't have situations. That's the reason why I said you adaptation. Adaptability is the only technique that human makes. Okay, fine. So, yeah, yes. Now, let's come to the next point, next chapter. So, this is very important chapter. That chapter is shear strength, and out of all the engineering properties so far we have discussed permeability, compressibility, and shear strength. Shear strength is a very important out of engineering property. This is very important out of engineering properties. So you take any engineering property, it is going to be very important because this idea of the shear strength. So what is shear strength? We will see later. But I am telling you, this idea of the shear strength is required for the stability of slopes. Required for stability of slope cuts, comma, embankment, comma, foundations. Everywhere you take any civil engineering structure, the stability is going to be important. Stability means the soil mass should not fail. Stability means soil mass should not fail. And the only thing that resists everything is nothing but the shear strength. So this is very important out of all the engineering properties. So I'm using the blackboard today because we are getting some problems every day in the whiteboard. The lagging problems are there. So that's the reason why I'm using the blackboard. So I hope you'd like to enjoy this. Okay, fine. No one enjoys dark. When you enjoy dark, then only you can enjoy the light also. So enjoy the dark first. Yes. So that it can be saved also, it will be there now. Okay, fine. Now let's come to the shear strength. So if you look over the shear strength, what is mean by shear strength? And see for that, just I will go to the previous things. Now stop your writings or stop your doubts and start listening the concepts. Hi sir, it's easy to sit in a class with AC for a number of hours, but it's very difficult to sit for 4 hours for a device even in season numbers. Okay, fine. If you are not comfortable with this one, I can go to the whiteboard also. So, okay, fine. Let's go to the whiteboard. Okay, now I hope everybody is able to look this. Okay, fine. Okay, so with the peoples, so as a lot of people are asking me to go with the black only, so I'll be going the black. And the people who like white, so for today, you please try to go with the black. And if you still have any problem, then I can change that. But even personally, I do like black. So now come to the, yes. So shear strength. So already I have been discussed the shear strength. So now in the earlier chapters, I have discussed the shear strength, the stop your things, and let's start the class. It's already a lot of time is there. Okay. So now, see. Okay, fine. So now let's come to the point over here. You see, so far in the earlier classes, I have been discussed about chapter number 7. In chapter number 7, we discussed about in chapter number 7, we discussed about stress due to the self-weight of the soil mass. Yes. In chapter number 10, we discussed about a stress due to external loads. So by combining chapter number 7 and chapter number 10, we discussed about chapter number 11 as consolidation. There I told you, Baba, whatever the loads we applied on the ground is nothing but the compressive loads. And due to that compressive loads, what happens? Soil will undergo some compression. And whatever the deformation, the lateral deformation, I told you as settlement. Now, what is meant by shear strength, sir? So listen. If this is a framework structure, and let's say this is a ground level. Now, whatever here, it is nothing but the footings are not. Whatever this is nothing but the footing over here. Yes. So you know that due to this load coming from the column. See, this is an external structure. There is an external structure, and you see whatever this is nothing but the ground level. So now in the case of the ground level, if you see this entire is a soil mass or not, this is a soil mass. And now if you observe whatever the soil mass is under the stress, yes or no, whatever the soil mass is under the stress. So due to this external load, the soil mass will be under stress in all the directions, vertically and laterally due to the soil mass and vertically due to the external loads, which means when an external load is applied on the soil mass, the soil is under stress. So now what I want to say here is, at a point in a stressed soil mass, at any plane, you take any plane at a point in a stressed soil mass. So now let me take this point over here, and you know this is nothing but the soil. I hope yes, these colors are fine for you. So now you take any plane passing through that point. So at a point in a stressed soil mass, at a point in a stressed soil mass, at any plane, you take this plane or that plane, at any plane, there exists one stress normal to plane as normal stress. There exists one stress normal to plane as normal stress. You see, at any point inside of the plane, at any point there exists one stress normal to plane as normal stress, and tangential to plane as tangential or shear stress. Tangential or shear stress. So at any point in a stressed soil mass, at any plane, there exists one shear stress and one normal stress. And if I take 2D, so this is one plane, right? In 2D, in two-dimensional, how many planes are there? X plane and Y plane. In the case of the X plane and Y plane, see, there exists one normal stress and there exists one shear stress. That shear stress is going to be represented with the tau, and normal stress is going to be represented with the sigma. Normal stress is sigma and shear stress is going to be tau. So now, in the case of the two-dimensional figures, in two dimension, there is in x direction sigma xx and y direction tau xy, means in that plane only. So this is x plane. Similarly, in y plane, sigma yy tau sorry here. Yes. So in the case of the x plane, so now it is going to be tau yx sigma zz. Sorry, sigma y. So in the case of the two-dimensional, you are going to see on every plane, there is a normal stress and there is a tangential to plane. So if it is x plane, on the plane there is a normal stress and there is a shear stress. On the y plane there is a normal stress and there is a shear stress. So So now this is X and Y. And in the case of the 3 dimension, in 3D, in X, sigma XX, tau XY, tau XZ. Now in Y, tau YX, sigma YY, tau tau YZ. In the case of the jet plane, tau ZX, tau ZY, sigma ZZ. So these are the stresses that you have learnt in your solid mechanics where you are going to see. So now in the case of the 3-dimensional, in every plane, 1 normal stress, 2 shear stress. In 2-dimensional, in every plane, 1 normal stress, 1 shear stress. So at any point in a stressed soil mass, at any plane, there exists 1 stress normal to the plane as a normal stress and a tangential to the plane as tangential or shear stress. So in the case of the 2-dimensional, this is the condition, and in the case of 3-dimensional, this is the condition. So now can you please tell me, in the case of 3-dimensional, at a particular point, at this point in 3-dimensional, if it's a 3-dimensional, at a particular point, how many number of stress components are there? In X direction 3, in Y direction 3, in Z direction 3. So total 9 components are there. But our analysis is all about whom? 2-dimensional only. So now, sir, what is the purpose of this normal stress, sir? The purpose of the normal stress is normal stress represented with a sigma. Normal stress is tends to squeeze the soil. Tends to squeeze the soil, which means consolidation. So far and so good, whatever the discussion I have made. So far and so good, whatever the discussion I have made is about consolidation only. Have I discussed any shear stress up to that point now? No. I discussed all the vertical stresses only and I represented with sigma, sigma, sigma. And that sigma is known as normal stress. And what is the responsibility of normal stress? Tends to squeeze the soil mass. And now you see, come to the shear stress. In the case of the shear stress tau, see, you know the shear stress means, you see, if this is a plane and if there is a stress acting along the direction of plane, this is a plane, right? Let's take this plane as MN plane. So along the MN plane, the stress is going to be tangential stress and shear stress. And now you observe, see everybody, let's take my palm. This is a plane. And for this plane, if the force acts normal, this is going to be the normal force per cross section area known as normal stress. And if this is a plane, if there is a force acting along the plane, this is known as shear stress. And shear stress means shear force per, now this is going to be surface area. For shear force, surface area. For normal force, cross section area. So now any plane you take, one force normal, tangential, other force normal. Now let's come to the shear stress. See the shear stress, this is tends are responsible for displacing the soil, which means shear failure. Shear failure. Sir, can you please tell me one example, sir? Yes, sir, there are a lot of examples, sir. For this one, the best example I can give you is the landslides. I hope everybody observes the landslides. Just imagine a landslide. I hope in every rainy season, and especially in the northeastern countries, so every rainy season, you can see a lot of or a huge massive landslides are going to be happen. Yes or no? So in the case of the landslides, what you observe is a huge amount of the soil. A huge amount of the soil will slide along the length. A huge amount of the soil will slide along the. So now in the case of the landslides, as a soil must slides along. See, this is along the length means, is it a shear failure or normal failure? That is a shear failure. And who is responsible for that? Shear stress. Now you tell me, in the case of the geotechnical engineering, whatever the structure you construct, whether it is an embankment or a slope or at the dam or foundations, there is a failure to the soil, and that failure is going to be shear failure. See, now I am a soil mass. If you apply some load, definitely there must be some resistance to me or not, means some resistance would be there. If you apply the load, directly I am not going to be free. If you apply the load, I will take that load up to certain extent. And beyond that, if you apply a load, for example, my capacity is, let's say 100 kgs. I can bear a weight of 100 kgs. If you apply 120 kgs on me, can I take that load? No, I will be fail. Here the fail means I cannot take the load. And if you apply 90 kgs on me, yes, I can take the load. Similarly, in the case of soil also, while you are constructing, this is a structure. Due to this structure, soil will be under stress. And at a point in this stressed soil mass, and you take any plane, there is a shear stress. And if this shear stress is more, then there is a shear failure. Are sir, then how come I find out this maximum shear stress, sir, that soil can be take? That is known as shear strength. That is known as shear strength. So now let's see what is the shear strength. Let's see what is the shear strength. So the shear strength means ability of a soil to resist shear ability of a soil mass to resist shear failure. So strength means resistance to failure, and shear strength means ability of a soil mass to resist the shear failure. So now at critical condition, now you go for the backward. You see, you please observe whatever the here, this is nothing but the shear stress or not. Then what is the shear strength? Ability of a soil mass to resist the shear stress. If this is the shear stress, then can I say this is nothing but the shear strength? Because along the plane there is a shear stress, and in opposite to that, you observe over here, in opposite to that, what is the strength? Now that is going to be the shear strength. So at the critical condition or at failure, shear stress at failure is equals to shear strength, which means tau. Shear stress at failure is nothing but a shear strength. See, in the case of the shear strength, for example, let's say I have some strength. I don't know my strength. Now, you apply some 10 kgs. You apply some 10 kgs. So just imagine myself as a body. So you apply some 10 kgs. Now, if I take the 10 kgs, I have some resistance, means I have some strength to bear the 10 kgs. Now you apply 20. Still I can take the load. Now you apply 30 kgs. Still I can take the load. For example, let's say you applied 40 and 50. I can take the load up to 50. So if you apply 50 also, I can take that load without any failure. Now you apply 51 kgs. 51 kgs. So by the time you apply 51 kg, one more kg, I said, please remove the load. Please remove the load. What is the meaning of please remove the load? Which means beyond 50 kgs, I am not able to take the load. Beyond 50 kgs, I am not able to take the load. Then what is the strength of mine to take the load? 50 kgs. Where it came? Is it came after failure or yet a failure? Yet a failure. How much load you applied? 50. That's the load applied or stress applied. And how much resistance I got? 50. So yet a critical condition, whatever the shear stress at failure is equals to the shear strength. See, if this is a shear stress, opposite to this one is a shear strength. When both are going to be same, then the soil is in a critical condition. And whenever the shear stress is more than the shear strength, then the soil will slide. So in the case of landslides, the shear stress is more than the strength, so soil will slide. That causes a shear failure. So now our point is about this shear strength only. At first I discussed what is meant by the shear stress and what is meant by the normal stress, and now what is meant by the shear strength. Sir, it's better to give PDF in white background so that we can take black and white Xerox copy for study. You can take the color Xerox also. You don't need to worry about that. I think so. You can take that also, right? It's an equilibrium. Instead of equilibrium, we have to say it as a critical condition. Now, I hope I'll write down the white so that there is no color contrast also. Now, the question is, now, RSR, listen first. RSR, you applied the load. When you applied the load, there is a normal stress and there is a shear stress. And you said that soil will have some ability to resist the shear stress. Sorry, shear stress known as shear strength. From where the soil will have the shear strength, sir? From where the soil will have the shear strength. So now, from where the soil will have shear strength? Soil derives its shear strength from number one, interlocking between particles. Interlocking between particles. The meaning of interlocking between the particles is, you see, these are the two particles. These are the two particles, and there must be some contact between the particles or not. So there must be some contact between the particles. So interlocking between the particles, which means contact between the particles. Mind it. Question number one for you. Does loose soil has more strength or dense soil has more strength? Loose or dense? Dense. Because in the case of the dense, the particles are going to be closely packed. When the particles are closely packed, the contact between the particles is going to be more. So the more the contact, the more the locking between the particles. Compared to loose, dense has more packing. So in the case of dense soils, I told you earlier, strength is more. Yes. Similarly, now coming to the B. In the case of B. So now the B is frictional resistance between particles. And this is very important thing, frictional resistance between the particles. Sir, what is meant by frictional resistance, sir? Sir, when there is a shearing, you please observe. I will draw this figure again. If this is one element and if this is a other element, now the interlocking depends upon the contacts between the particles, and if there is a shear stress acting over here, then the particles will slide one over the other or not? Yes or no? When the particles will slide one over the other, it is going to be create a friction. Yes or no? And the more the friction between the particles, the more the strength. Now, when you walk over a marble floor and when you walk over a concrete floor, when you walk over a marble floor, when you walk over the concrete floor, which one has a more friction? Obviously concrete. Yes or no? So the friction is a property of the material. What is the material we are using here? Soil. So every soil must be having some friction. And now whatever the frictional resistance between the particles, that also comes into the existence. And the last one is C, cohesion, means attraction between particles. Attraction between the particles. So now what I want to say here is, what I want to say over here is, see, any soil mass will take the strength from any of these things. Now out of this, the note point is, granular soils will derive its strength from interlocking and friction. Interlocking and friction. Granular soils will derive its strength from interlocking and friction, whereas fine grained soils are clays mixed with other soils has strength from friction and cohesion also. Friction and cohesion. See, granular soils means cohesionless soils, Nana. Granular soils means cohesionless soils. So granular soils or cohesionless soils will derive its strength from interlocking. Interlocking means contact between the particles, and friction means while they are moving, there must be some resistance between the particles. Whereas in the case of the clays mixed with some fines, then there is some cohesion and there is a friction. Sir, what if it is a pure clay, sir? In the case of pure clays, in pure clays, which means plastic clays, strength is due to cohesion only. Strength is due to cohesion only. So I said to you, these are the reasons soil derives its strength, and out of those, if I ask you, granular soils will derive most of its strength from interlocking and friction, and fine grained soils will be having friction and cohesion, whereas for pure clays, and generally for pure sand C is equals to 0. What is meant by C, sir? C means cohesion. What is meant by C over here? So I can write down that point also. Cohesion, C is equals to 0 for pure clay friction, which means phi is equals to 0, where phi is angle of internal friction. So these are the things that I have been discussed at first. What is the definition of the stresses, and what are the responsibilities, and what is the shear stress, and how the shear strength is going to be developed. So now I need to find out the shear strength. What is the shear strength? What is the shear strength? See, now if you observe in this element, let's take this element again. The shear strength depends upon the shear stress at failure. Yes or no? The shear strength depends upon the shear stress at failure. So now what I do is I take the same element. This is a soil element where the normal stresses are going to be present. Now along this plane, this is Mn, and at any point you take, it has a normal stress and it has a shear stress. So if I want to find out the shear strength, first of all I need to find out the shear stress. So whatever the shear stress at a failure is nothing but the shear strength. So let's find out the shear stress. Now I am going to take this element as a rectangle element. Now I will be taking the same element as a rectangular element. For the analysis, now I am going to take into a rectangular element. So now you see whatever the stress acting on the tops, this is going to be a vertical stress. Yes or no? So now you see these are going to be the stresses, and now this is a plane where we are going to discuss. On this plane, this is a normal stress and this is a shear stress. Now my dear students, I am asking you a question. This is a horizontal plane, right? Everybody have a look. This is a horizontal plane. See whatever the cursor I am showing you, horizontal, and this is a vertical. See, on the horizontal and the vertical plane, is there any shear stress acting over here? No. So on the horizontal plane and vertical plane, there is no shear stress. If there is no shear stress, such a type of planes we are going to call it as principal planes. Such a type of planes we are going to call it as principal planes. So now principal planes. What is mean by principal planes, sir? Principal planes means the planes on which shear stress is 0. The plane on which shear stress is going to be 0, or whole stress is normal stress only, and normal stress acting on such planes is principal stresses. So whatever the plane you take, whatever the plane you take, the planes on which shear stress is going to be 0, and that planes are known as the principal planes, which means whatever the normal stress acting over there are going to be the principal stresses. So now, at any point, you see, I'll take this point, at any point in a stressed body, there exists three mutually perpendicular planes on which shear stress is 0. On which shear stress is going to be 0. See, at any point in a stressed body, there exists three mutually perpendicular planes on which shear stress is going to be 0. And that type of planes are going to be the principal planes. And how many planes are there? 3 planes. You observe, this is a point, this is a plane you have seen. This is a one plane. This is one plane where the shear stress is going to be 0. This is one plane where the shear stress is going to be 0. And the other one is going to be perpendicular to the board. Other one is going to be perpendicular to the board. So which means 1, 2, and 3. There exist 3 planes, but we are discussing about 2D or 3D? 2D. So with respect to their stresses, and those stresses are going to be in an order of the magnitude, So now those stresses are in its magnitude as we call sigma 1 as major principal stress, sigma 2 intermediate principal stress, sigma 3 as minor principal stress. Minor principal stress. So stresses will be acting less on all the directions. Stresses would be there. Okay. Yes, here also there is a stress, and here also there is a stress. On all the directions, the stresses would be there. So now, whatever this plane, I am going to take again. I will be taking this plane once again. Yeah. So there exists 3 mutually perpendicular planes on which shear stress is going to be 0, and such type of planes are going to be the major principal planes, and the stresses are going to be in a magnitude: major principal stress, intermediate, and minor principal stress. So in 2-dimensional, means in 2D analysis, we neglect intermediate, you can simply write, we neglect sigma 2. We neglect sigma 2. Array sir, in pure clays, due to cohesive nature, attractive force are more and the friction will be there. Array Baba, friction is different and attraction is different, Nana. Attraction between the particles is cohesion. You are saying, sir, due to cohesion nature, there is a friction. So it's not the same. So don't worry about that. So not understood total cohesion. Array, I did not said anything new over here. I did not said any point. So far, I did not discuss any concept. I was just discussing you. You take any point in this point. Now, I see. Fine. Those who are having a doubt, now it is going to be clear. Let me show you that. Now you see there is an element. This is a soil element, and if you observe, whatever the stresses acting on this plane, this is going to be the major principal stress, and whatever the stresses acting on this plane is going to be the minor principal stress. Because I just said you see there are planes. Is there any shear stress acting on the planes? No. Is there any shear stress acting on the planes? No. Please understand. Is there any shear stress acting on the planes, on the outside planes? No. Which means these are principal planes. And I said you for the two-dimensional, we neglect the intermediate. So we take major and we take minor. Sir, why you take major vertical and why you take minor, sir? Sir, you please see, sir. The load is in which direction, sir? Vertical direction, sir. So the maximum stress will be on the vertical direction. So I took the major principal stress as sigma 1, minor principal stress as sigma 3. And if this is going to be the major principal stress, then whatever the plane here, I can write this one. See, if this is a major principal stress, and this is known as major principal plane, and this is known as minor principal plane. Major principal plane and minor principal plane. Who said is shear stress is horizontal, sir? Yes. First, listen to the concept, Ray. First, listen to the concept once of a. First, I'll write everything. Then you can ask me the doubts. Even though how many times I say also, you don't be about that. Now, let's say, see, this is a stressed element or not. Now you see, let me take inside a point, and along that point, let's take this is a plane. Along the point, let's take this is a plane. So this is a point over here. Now, whatever the stresses acting on this plane, perpendicular to the plane, normal stress, and along the plane, shear stress. So let's take this plane as MN plane, whatever the plane, and let's take the angle made by the plane, any plane. This is a plane, right? This is any plane. Sir, should I have to take only 10 degrees, 20 degrees? It's up to you. You can take any plane. So if this is a major principal, this is a normal stress and this is a major principal plane. This is a minor principal stress, this is minor principal plane. This is any stress, this is going to be any plane. Now I want to find out the stresses on this plane. So now you see, if alpha is the angle made by any plane with respect to major principal plane. You see, this is a major principal plane, then this is also going to be the major principal plane or not? You observe, because see, this is a major and this is major. Major is horizontal over here and the minor is going to be vertical over here. So don't think this alpha as an angle made with respect to horizontal. Do think it as angle made by any plane with respect to major principal plane. Okay. So now I need to find out this sigma and tau. For this sigma and tau, for the sigma and tau, Now, let me take an element over here inside. See, I'm taking a small element so that you know whatever this stress here, this is going to be sigma 3, and this is a sigma 1 only, na? And this is also going to be sigma 3 because the balancing of the stresses would be there. So this is going to be sigma 1, and now this is going to be sigma, and here it is going to be tau. And if alpha is the angle made by the any plane with respect to the major principal plane, now you can find out the sigma and the tau by using a formula. See, if you use this one, you can derive the equation. I am not going to derive that entire equation. So I can say that sigma is equals to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 alpha. See, the same equation you have seen in the case of the strength of materials. The people who have attended the strength of materials, you can take it, means you can remember that. Yes, don't worry, I'll be explaining you the same thing in the next topic. Sir, how this equation is going to be derived, sir? Just wait for a moment. Just wait for us some minutes. In the more circle, I am going to discuss about that. Don't worry about that. So now, if this is going to be the normal stress and is going to be the, means now the shear stress is going to be sigma 1 minus sigma 3 by 2 sine 2 alpha. So there is a derivation for this. I am not going to show any derivation over here. I don't want to waste your time. So if there is a major principal stress acting on the plane and a minor principal stress, then whatever the normal stress and shear stress acting on any plane inside of the soil mass can be found out by using this equation. So this equation is going to be very, 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 very important relation. So please remember this equation. This is very, very important relation. And based upon this only a lot of things are going to be happen. Now you can ask me a question. Hare sir, you are saying, see, this is a plane and I can find out the normal stress and shear stress by knowing sigma 1 and sigma 3. Then now my question is, you know the shear stress, no sir? Then what is the maximum shear stress acting on this plane, sir? Now, please tell me. For tau to be tau maximum, for tau to be tau maximum, you observe here, when the tau becomes tau maximum, if the sine value is going to be 1 or not, what is the maximum of sine value? Sine 0, 0, sine 90, 1. So the maximum sine value is going to be 1. So if sine value is maximum, and what is the maximum sine value? Please tell me. What is the maximum sine value? The maximum sine value is going to be sine 2 alpha is equals to 1. And then 2 alpha is equals to 90 degrees and alpha is equals to 45 degrees. So what is the meaning of alpha is equals to 45 degrees, sir? If a plane is making an angle of 45 degrees, then the plane is going to be having a maximum shear stress. Maximum shear stress occurs on a plane having angle of 45 degrees with respect to major principal plane. Okay. So when the tau becomes tau maximum, when the sine value is going to be maximum, then if this is the case, then what is the tau max? Can you please tell me? Sine 2 alpha, sigma 1 minus sigma 3 by 2. This is going to be the maximum shear stress. So just now I said you, if this is an element, why I have taken this element? I told you. If you still have a doubt, you go to the 7F. I took this element. This is an actual element. What is this element? So this is the element. I took the same element over here and I have converted it into rectangular element, and I told you on the top, on the sides, there is no shear stress. Such type of planes are known as principal planes, and at any point in a stressed body, there exists three mutually perpendicular, but we are discussing about two dimension. So when we discuss about two dimension, I can see horizontal plane, I can see vertical plane. Whatever the stress on horizontal plane is major, so this plane is major principal plane. Whatever the stress on the vertical plane is minor, this is known as a minor principal plane. And if you take any plane, then you can say there exists a normal stress and there exists a shear stress. Don't think this is a gamma, that's a tau. Please make sure that is a tau, that's not gamma. So now, see, sir, how this equation is came and how you are making the maximum. I'll be explaining you with much more simpler concept known as Mohr circle. Much more simpler concept known as Mohr circle. So now let's see that Mohr circle. Let's see that Mohr circle. So I'll be take this one. Yes. So now, whatever the plane I have, I have taken this element and I explained these values, right? So now there is a one more method known as Mohr circle. There is one more method known as Mohr circle. In the case of the Mohr circle, and mind it, this is a graphical representation. Mohr circle is graphical representation of state of stresses. State of stresses. So how we are going to find out the Mohr circle, sir? Now, see, this Mohr is a scientist who developed a theory and a graphical solution to determine the normal stress and shear stress acting on any plane. Acting on any plane. You take any plane, either you can go by means of the formulae, or you can go by means of the Mohr circle. Now I am going to discuss. So now this Mohr circle consists of this Mohr circle consists of a graph on x-axis. We take the normal stress On y-axis, we take the shear stress. According to Moore, the shear stress is a function of the normal stress. Now, so what is the meaning of this one, sir? Now you please look over this figure once again. Once again, please. What is the stress that you are applying first? Is it a vertical stress or a horizontal stress? Vertical stress. Vertical stress is nothing but normal stress or not? Yes or no? Keep in your mind. Now, this is a soil mass. When you apply the normal stress, then only the shear stress will be developed inside of the soil mass. Question for you. Without normal stress, is there any shear stress? Think and say. Without normal stress in a soil, is there any shear stress? No. Without the shear stress, there can be normal stress. Without shear stress, there can be normal stress. I can say it as a principal stress. But without normal stress, there is no shear stress in a soil element. So the shear stress is a function of the normal stress. The shear stress is a function of the normal stress. So what's Moore's hardness number? अरे आपके दिमाग ये कहाँ है भैया? ये anonymous attendee, you please say the name. That's Morse is not only this one. Moore has done some experiments in environmental engineering also. There is a hardness. Sir, alpha is minor principal नहीं sir. अरे रे रे क्या रे भाई? देख लो एक बार पूरा से देख लो here. This is alpha with respect to whom? Is it major or minor? This is major principal plane. Okay. So now there is a normal stress and there is a shear stress. So first of all, plot the normal stresses and shear stresses on the element. So now let me draw the elements separately. So you see, now at first this element is there or not? So in this element, there is a major principal stress and there is a minor principal stress plane. So I am taking you different planes. Please listen. Do not try to ask any question in between. Please you listen first this one, then only you can question me. So you know this is nothing but the sigma 1 and you know this is nothing but the sigma 3. So now I am going to write a set of stresses. What is the shear stress over here? 0. Sigma 1 comma 0. What is shear stress over here? Sigma 3 comma 0. So what is sigma, sir? X, sir. X and Y is going to be tau, sir. Sir, on this plane, whatever this plane, this is nothing but major, right? This is a major plane and this is going to be the minor plane. I told you clearly, this is a major plane and this is going to be the minor plane. So now, at first, you insert the index, means the coordinates are x comma y. What is x? Sigma. What is y? Tau. On the major principal plane, sigma is sigma 1, tau is 0. On minor principal plane, sigma 3 and this is going to be 0. So now let's plot those points. If I plot those points, this is going to be sigma 3 and here it is going to be sigma 1. This is going to be sigma 3 and here it is going to be sigma 1. Yes. So somewhere over here it is going to be sigma 1. Just I am drawing the figures. This is sigma 3 comma 0 and this is sigma 1 comma 0. What is the meaning of 0? Y0 means point lies on x-axis or not. Now the biggest question for you is, you see this question, you see this equation, what is the meaning of sigma 1? Major principal stress. What is the meaning of major? Maximum. What is the meaning of major? Maximum. What is the meaning of sigma 3? Minor. Minimum. Now you tell me, in this horizontal plane sigma 1, vertical plane sigma 3, and you take this sigma value, do you think does a sigma can be more than major principal stress? No. Does sigma can be less than minor principal stress? No. So the maximum normal stress is major principal stress. The maximum normal stress on this plane sigma is major principal stress. The minimum normal stress, for example, let's take alpha is 0. What is meant by alpha 0? Think What is mean by alpha 0? When alpha is 0, this MN plane is horizontal or not? When the MN plane is horizontal, that is major principal plane, then sigma is equals to sigma 1. When alpha is equals to 0, you please insert the alpha equals to 0 over here. I will explain. If you insert alpha 0, then what is cos 0? Cos 0, 1. Sigma 1 plus by 2. Sigma 3 plus by 2. Minus sigma 3 by 2. Sigma 3 gets cancelled. What is the answer? Sigma 1. So the maximum normal stress is major principal stress. The minimum normal stress is going to be minor principal stress. So sigma will be always, or I can write in this fashion. You know that this sigma 3 less than or equals to sigma less than or equals to sigma 1, which means sigma, which means stress at any point will always lies between sigma 3 and sigma 1. I hope you understood this point over here. So now let's see how to draw the Mohr circle. How to draw the Mohr circle means first, after making sure this is sigma 3 and this is sigma 1, and can I say this is sigma 3 which is a minor principal stress, this is sigma 1 which is a major principal stress. Is there any normal stress less than this one? No. Is there any normal stress more than this one? No, because the values are going to be lies between major and minor. The meaning of major, the name itself says major maximum, minor minimum, and in between you take any point, you take any alpha, whether the alpha is 10, 20, 30, then sigma will lie somewhere in between over here. So now draw the normal stress on x-axis, draw the shear stress on y-axis, placing the points, keep the shear stress ordinates, and then now draw a circle by taking the radius. You see, this is nothing but the extreme points are not. Major and minor principal stresses are extreme points of a circle. Extreme points of a circle. Then if I take this is going to be the center, what would be the radius, please? What would be the radius over here? You please tell me this radius value. So this is sigma 1 and this is sigma 3. What about this total value? Sigma 1 minus sigma 3. So let's take this as a center. If that is a center, now whatever the value over here is known as sigma 1 minus sigma 3 by 2. This is the radius. So major and minor principal stress are extreme points of a circle, and take radius. Now draw a circle with a radius r is equals to sigma 1 minus sigma 3 by 2, with r is equals to sigma 1 minus sigma 3 by 2. Now from here I am going to draw a circle . So now I am going to draw a circle. So this is a circle. Yes. So now this is a circle and this circle is going to be the more circle. So now you please focus on the means you please focus on the upper level only. You don't need to focus on the downstream means below the x-axis because I am going to discuss everything above the x-axis only, because whatever the discussion I am going to make is for the positive stresses only, not for the negative stresses. So now this is sigma 3 and here it is going to be sigma 1. You take any point will locate on the x-axis. Any point of the normal stress will locate over here. So now point number 1, draw the Mohr circle by taking sigma 3 and sigma 1 as extreme points. So now my question for you is, what would be the maximum shear stress over here? See, this is the tau, right? Now now if you see this value, what I am drawing as a dotted line, and can I say this value is going to be the tau maximum or not? Because the entire value over here, this value, whatever the value I just showed, this is a y value or not? So the y value, this value is going to be tau maximum. So what is the maximum shear stress? The maximum shear stress is going to be just nothing but a radius or not, which is nothing but radius. So then what is the tau maximum over here is equals to sigma 1 minus sigma 3 by 2, because he is a radius or not. So now from this I can say whatever the radius yes, so that I remove the entire figure. Now please observe, this is sigma 3 and here it is going to be sigma 1, and whatever the radius is going to be sigma 1 minus sigma 3 by 2. I hope you understood this. So first of all, drawing the Mohr circle. Everybody observe the Mohr circle. How to draw the Mohr circle? Major and minor principal stresses are extreme points of circle. Draw a circle with a radius of sigma 1 minus sigma 3 by 2. Okay. So now what is the maximum shear stress? Tau maximum is equals to sigma 1 minus sigma 3. Maximum shear stress tau max is equals to sigma 1 minus sigma 3 by 2. And now if this is a maximum shear stress, then what is the total maximum stress? What is the total vertical stress? What is the from here to here? Can you tell me what is the total normal stress? What is the total normal stress? See, this is the point, right? So now this is the point. This point represents the Mohr circle represents. Draw a circle with a radius of r is equals to sigma 1 minus sigma 3 by 2. So and Mohr circle represents set of sigma comma tau. See, on this Mohr circle, if you observe, definitely this is going to be sigma 3 comma 0, this is sigma 1 comma 0, and this is somewhere you can see there is a x. What is the x? Sigma, and what is y? Tau. So now whatever the value I have, What is this? This X is going to be the shear stress, means the normal stress acting on this plane or not. So now if this is sigma 3, if this is a sigma 3 from here to here, this is going to be sigma 3, and this total value is going to be, can I write as a sigma 1 plus sigma 3 by 2? Yes. I hope you understood this. Sigma 1 plus sigma 3 by 2. So the radius is sigma 1 minus sigma 3 by 2, and sigma 3 plus sigma 1 minus sigma 3 by 2, then it is going to be sigma 1 plus sigma 3 by 2. I can write a normal stress on a plane of maximum shear stress. Sigma is equals to sigma 1 plus sigma 3 by 2. So these are the points that I am writing. See the questions I am some of the people. What about sigma 2, sir? Sir, you please look over here, sir. You will get to know what about sigma 2, sir. And what about sigma 2, sir? Why sigma 3 first, sir? Why sigma 3 first, sir? Sir, आपको दिमाग है तो if you ask this type of questions, then definitely, are you a civil engineer first of all? Are you a civil engineer or what? I am telling you clearly, this is nothing but x comma y. Okay, fine. I have to write the axis also. Okay, x comma y represents sigma comma tau on the major principal plane. On the major principal plane, there is no shear stress. Somebody is asking why sigma 3 first, sir. Sir, I am not writing sigma 3 first, sir. That is the magnitude, sir. Sir, in the case of x comma y, 5 comma 10, sir, 5 will come first or 10 will come first, sir? 5 will, sir. Questions also. Okay. So now, if this is the condition, let's see. So normal stress acting on a plane of a maximum shear stress, this is going to be sigma 1 plus sigma 3 by 2. But what we actually require, to tell me please, what we actually required is nothing but the stresses acting on this plane. The stresses acting on this plane. So now there comes, I'm going to introduce a new topic known as the topic known as a pole point. So now this point is very, very important in the case of the GATE examination. So you please look over here. Now, so let's take the same thing. I'm going to take the same figure. Now I'm going to introduce a topic known as a pole. So you please observe this pole point. The meaning of pole is, this is the pole point. So this is a pole. What is meant by pole, sir? The pole means simply origin of planes. The pole means simply origin of planes. Sir, what is meant by this pole? Why we have to use this one, sir? See, what is the meaning of origin of planes? In this plane, you see, whatever this is nothing but major, and whatever this is nothing but minor, and this is any plane Mn. This is any plane Mn. So here, in this point, from this point, every other plane is going to be originate or not. So you know this is nothing but minor, right? So this is minor plane and this is a major plane. So now you know that what is the meaning of pole is origin of the planes. Or in other words, I can write or the plane or point at which maximum major and minor principal planes coincides. Major and minor principal planes coincides. So wherever the point, the major principal plane, this is the major principal plane and this is the minor principal plane, they are going to be intersect or coincides or not? Coincides or intersects, that you are going to call it as a pole point. That you are going to call it as a pole point. And now you see any plane Mn will also pass through pole. Yes or no? So any plane Mn will also pass through pole. So now with this, can I say yes, then corners also pole? Yes, then corners also, see, this is also going to be a pole point over here. You can take any point, this is also going to be a pole point. So whatever the point where the major and minor principal plane coincides and the plane should pass us, any plane Mn will pass us through that pole point. So now that point is known as a pole point. Now let's see, coming to this figure, you observe how to draw the major principal plane. So now everybody have a look. Now the coming to the point number 3. Point number 1, major principal plane, minor principal plane, drawing the Mohr circle. Now point number 2, pole. So this is point number 1 and coming to the point number 2, how to draw the pole. Now listen carefully. I'll ask you one question. What is a major principal plane? Is it a horizontal or vertical? Is it horizontal or vertical? Horizontal. Yes. Wherever the major principal stress is there, this is the major principal stress. And through this major principal stress, draw a line which is parallel to major principal plane. Through this sigma 1, through the sigma 1, draw a line which is parallel to major. See, this is a parallel or not? Now you observe, this is a major principal plane and this is sigma 1 and this plane is going to be this one, and I can write this one as a major principal plane. Major principal plane. Sir, why you have taken this major principal plane, sir? On the Mohr circle, whatever the plane parallel to the major plane, we'll call it as a major principal plane. Are A horizontal, AB horizontal, this is horizontal, this is horizontal, both are parallel, so I am going to take it as major principal plane. Similarly, if you see, this is a minor principal plane or not? This is a minor principal plane. So now what I do is I will draw one more plane passing through the minor principal plane. See, you observe, you know, this is a minor principal plane. Minor principal plane. So now, how to find out or locate the pole point? In Mohr circle, draw major and minor principal planes by as draw major and minor principal planes exactly parallel to the planes on soil element. So exactly I am drawing the planes on soil element. On the soil element, this is a major principal plane. So parallel. This is sigma 1. Where it is acting? Sigma 1, major principal plane. Similarly, now what is this? Sigma 3. Sigma 3 is acting over here. What is this plane? Minor principal plane. Draw mirror. Draw the mirror. Mirror means here exactly parallel. Now this is going to be minor principal plane. Now, just now I told you, wherever the point at which major and minor principal plane coincides or intersects, that point can be taken as a pole point, right? Now, can I take this point? This is known as a pole point. So now, can you please tell me what is a pole point? The pole point is a point at which major and minor principal stress are going to be coincide. Now, if I know the pole point, so if you see the pole point, this is a pole or not? Yes. This is also going to be a pole point. Now, through this pole, any plane MN is going to be passing or not? Through this pole, any plane MN is going to be passing. So now, let's see. In Mohr circle, draw a line passing through in Mohr circle. If a line is drawn through pole, if a line is drawn through pole, it intersects at one point on circle represents the state of stresses sigma comma tau. So now, what is the meaning of this one? In a Mohr circle, if you draw a line through the pole point, it intersects at a point on a circle represents the state of stress. So now let's go to the one more way. Here, I want this MN plane. I want this MN plane, and this is the pole point. And you know that any plane MN also will pass through the pole. So any plane MN also will pass through the pole. Now let's draw a plane that is passing through the pole. Now that's it. Completed. About here, what is this plane? This is MN plane. And now just now I told you, if you draw a line through the pole, this line will intersect at one point on the Mohr circle. And this is the point where it is going to be intersect. And whatever the y-intercept is known as tau. And whatever the x-intercept, is known as sigma. And this point is known as sigma comma tau. That point is known as sigma comma tau. So now I hope everybody understood how to determine the stresses. It's not the end. It's not the end. So now this is a alpha. Here this is going to be alpha. So let me take the same stresses, same set of stresses over there. So I'm going to erase whatever unnecessary things are here. Whatever the unnecessary things are over here, I am erasing so that it will be clear for you. for better understanding. Yes. So now I hope the people are able to. See, this is the normal stress and this is going to be the shear stress. And from the properties of circle, if it is making an angle alpha with the edge, then it will be making an angle 2 alpha with the center. See, some of the students are asking, sir, why you have taken this as a major principal plane? I told you clearly, please understand, I am writing each and every point in Mohr circle, draw major and minor planes exactly parallel to the planes on the soil element. I asked you, in the soil, this is a major principal plane, exactly parallel. Can you see this is and this is parallel to each other or not? So when I ask you the exactly parallel, the meaning of parallel is going to be this one. Okay. So now let's see this condition. So from this, can you please tell me what is the total value over here? Yes. So in Mohr circle, if a line drawn through pole, it intersects at one point through the Mohr circle. Now this is the point. So what is this tau value? Now everybody, can I say this is nothing but a radius? What is this radius? Sigma 1 minus sigma 3 by 2, because this is center, right? And this is the point on the Mohr circle. Yes. And then what would be this value, please? What would be this value? That value is going to be cos 2 alpha is equals to, let's take it as x by r. What is r over here? Yes, opposite. Sigma 1 minus sigma 3 by 2. So then this x value is equals to, what is this value? Sigma 1 minus sigma 3 by 2 cos 2 alpha. And from here to here, what is this value, please? This value is sigma 1 plus sigma 3 by 2. So you see from this point to this point, the total value is going to be sigma. So I hope you please understand what is the sigma here. In this position, the sigma is equals to, please, this enter is going to be sigma. So if you want to erase and if you want to represent with other color also, we can represent that. So now whatever this dotted line is going to be sigma and this is going to be tau. So can you please tell me what is this sigma now? Sigma is equals to sigma 1 plus sigma 3 by 2 up to center plus whatever this coefficient is going to be sigma 1 minus sigma 3 by 2 cos 2 alpha. So at the end, the equation is going to be same as this equation or not? You please look over here. Sigma is equals to sigma 1 plus sigma 3 by 2 plus sigma 1 minus sigma 3 by 2 cos 2 alpha. So at the end, whatever the values we are going to get, this is going to be sigma. And what about the tau, sir? Sir, you please look over this figure, sir. You please take it as outside, sir. If I take it as outside, so I'm going to say, if this is going to be 2 alpha and this is radius, right? Sigma 1 minus sigma 3 by 2. And you know this position, whatever this point, sigma 1 minus sigma 3 by 2 cos 2 alpha. and this is going to be sigma 1 minus sigma 3 by 2 sine 2 alpha. Yes or no? Because sine is nothing but opposite by adjacent. So opposite is equals to sine into adjacent. Sorry, hypotenuse. So sine 2 alpha is equals to opposite by hypotenuse as sigma 1 by sigma 3 by 2. So then the opposite is going to be sigma 1 minus sigma 3 by 2 sine 2 alpha. From that figure, I can write sigma 1 minus sigma 3 by 2 sine 2 alpha. The same thing that I have been explained. This is with the Mohr circle. In the Mohr circle, you need to apply. I'm repeating the points again. Please understand now. Now I have completed the Mohr circle. So what is the purpose of this Mohr circle is you can easily define the values. Sir, why is it 2 alpha, sir? Sir, that is the property of the circle, sir. From the property of circle, sir, whatever the angle made at the pole point, this is the pole point, right? Whatever the angle, whatever this is nothing but the pole point, if the angle is at alpha over here, then with center, it is going to be 2 alpha. See, this is center, Nana. This is not some point. This is going to be center point. So up to center, you're going to see this value sigma 1 plus sigma 3 by 2. And beyond center, whatever this value, x is going to be sigma 1 minus sigma 3 by 2 cos 2 alpha. So now with this, I completed the Mohr circle. So how to draw this Mohr circle? Let me explain you once again. First of all, you please draw the major and minor principal stresses sigma 1 comma 0, sigma 3 comma 0 over here. Now a major and minor principal stresses are extreme points of a circle. So draw a circle with radius sigma 1 minus sigma 3 by 2. So you please draw a circle with the radius sigma 1 minus sigma 3 by 2. I have represented the radius also. And then once you draw the circle, then what is the maximum shear stress you are going to see? Sigma 1 minus sigma 3 by 2. And what is the normal stress acting on that plane? Sigma 1 plus sigma 3 by 2. All these are previous ESC bits. They can ask you, what is the angle made by maximum shear stress? What is the angle made by the maximum shear stress? 45 degrees. And what is the maximum shear stress value? Sigma 1 minus sigma 3 by 2. And what is the normal stress on a plane where the shear stress is maximum? Sigma 1 plus sigma 3 by 2. I have given you the proofs also here. You please look over here. And then we discussed about the pole. What is meant by pole? Origin of planes. The planes at which major and minor principal planes are going to be coincide. And any plane you draw, that plane should pass us through the pole only. Any plane you draw, that plane should pass us through pole. Now, how to fix the pole? How to fix the pole? How to fix the pole, sir? Sir, if this is a major principal plane, then you draw parallel to that. This is a horizontal major, and this is also horizontal major. And this is a vertical minor. This is a vertical minor. So now, after all days taking this major and a minor, once you know the major and a minor, this is going to be the pole point, and any plane should pass us through the pole point will make an angle alpha. So come on, you please tell me what is the meaning of alpha, please. What is the meaning of alpha? I told you. Alpha is an angle made by any plane with respect to major principal plane. Now, this is alpha. This is alpha. Angle made by which plane? MN plane with respect to whom? With respect to whom? Major principal plane. So once we draw that, then if you draw that plane with respect to major principal plane, then what is sigma and what is tau? You can directly get this value from the graph. This is numerically and this is graphically. Numerically and graphically, finally I have proved both are going to be same. So that's about the Mohr circle and okay. So first you have a break, and meanwhile you can see this. You can take a screenshots also. Please, within a minute, you please take a screenshots for everything. So let's have a break. It's 11:30 already. So let's have a break of 20 minutes up to 11:50. Yeah, after the break, I'm going to give some more conditions so that you can understand. See, in order to understand a topic, it requires some time. If you break your making of understanding in between, then you won't understand the later things also. That is the reason why I'm asking you, once you finish the topic, means once I finish the topic, then you check whether you understand the total concept or not. Yes, take a screenshot for this. Now, next one. Take the screenshots. Next. See, I am changing the slides so that you can take a screenshots. Next. So I'm giving a break. Please come by 11:50. I'm giving you the screenshots because see, meanwhile you can see during the break you can go through the previous notes so that you can understand much more. That's the reason why I'm asking you to take the screenshots. I'll be sharing the notes that's there, but I want you to look over. See, yes, I want you to go through the all the points. If you have a screenshots, you can have a look over there. And meanwhile, in this 20 minutes, you can have a grasp look so that you can understand the concepts much better. So, okay, that's all. Have a break. I'll meet you after at 11. Yes. So now let's come to the next session. For a soil, ground level can be called as a principal plane. Yes, my dear. We can call the ground level as horizontal. So you can take it as a principal plane. And now, you see, so we have discussed about this pole topic. Now, based upon this pole, I'll give you some statements and I'm going to ask you the pole also. So for some examples, I'm giving you the conditions. Mind it, I'm going to ask you, see, this type of questions has been asked in previous IES also. So look over here. So I hope the people have been here. So now let's see. So let's some more discussion for the pole. I'm going to take. I'll give you some elements. And you have to say me what is the pole. Number one. Sigma, 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 and sigma. Sigma, 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 sigma. So everywhere sigma. Now, I'm giving you 1 minute. What is the pole point? What is the pole point? Does the pole locates on the near to the origin, or does Mohr circle exist first of all? See, this is nothing but an isotropic condition or not? What is mean by isotropic condition? What is mean by isotropic condition? In at a point in all the directions property is same, then it is going to be isotropic condition. So at a particular point in all the directions, the stress is going to be same, right? So what is the major principal stress here? Sigma. What is the minor principal stress here? Sigma. See, I gave you, if this is a soil element, this is a soil element clearly, sigma 1, sigma 3. So what is the sigma 1 and sigma 3 I am giving you? Sigma 1 is sigma and sigma 3 is also going to be sigma. Now, if I draw a Mohr circle, then if I draw a Mohr circle for this, so sigma and the tau, if I draw a Mohr circle, what is the shear stress over here? The shear stress is going to be 0. If I draw a Mohr circle, then the Mohr circle is going to be a point. So now Mohr circle is a point. And this type of condition is known as isotropic condition. And for this, no pole exists. No pole exists. See, in this condition, the pole is not going to be exist. Why the pole is not going to be exist, sir? Because the Mohr circle is a point. That's it. So as a sigma 1 and sigma 3 both are same, as a sigma 1 and sigma 3 both are same, you know that Mohr circle represents a sigma 1 and sigma 3. As both are same, then the Mohr circle is going to be a point. I hope you understood this. Now, let's see. I'll give you one more condition. Let's take now. There is only vertical stress. Now let's take only vertical stress are there, which means sigma 1 is going to be sigma and minor principal stress is going to be 0. So now when the minor principal stress is going to be 0, you see wherever there is a minor principal stress, there is a pole point. Yes or no? Wherever there is a minor principal stress, there is a pole point. Now, if you draw the Mohr circle, if you draw the Mohr circle, now what is sigma 3? 0. And there is a sigma 1. Now if I draw the Mohr circle will pass through the origin. So here Mohr circle pass through origin. And you know what is the meaning of a pole? You know that, right? So wherever there is a minor principal point, you please look over this carefully. Where I have kept the pole point, wherever there is a minor principal stress, this is going to be the pole point. Wherever there is a minor principal stress, this is going to be the pole point. So now the pole point, pole is located at origin. So I hope you understood. This is going to be the pole point, because you know this is a major principal plane and this is going to be minor principal plane, because minor principal plane, major principal plane. Now similarly, the third condition, if I give you the third condition is going to be like, third, now you observe this is sigma and here this is going to be sigma. If you observe, see, I can represent you, this is also going to be a sigma. Okay, fine. Now in this condition, you please say, what is major principal stress? Sigma. And what is minor principal stress? Minus sigma. Sir, why it is minus, sir? Because tension, sir. Sir, you know that in the case of soils, in the case of the soils, you know that in the case of the soils, compression is positive, tension is going to be negative. You know it clearly. I said you in starting points itself. So now if I draw the Mohr circle, where does the Mohr circle locates? Please tell me. Now if I draw the Mohr circle, so observe. Now this is going to be a sigma, major principal stress sigma, and minor principal stress is also going to be sigma, but this is going to be negative. This is positive x-axis and this negative x-axis, and this is going to be y-axis. Yes or no? So now I hope everybody understood over here. Now I hope you understood over here. So now you see, if I draw the Mohr circle, that Mohr circle should be see why you are taking semicircles, sir. I'm discussing about positive axis, so that's the reason why I'm taking that one. So sigma 3 is also going to be sigma. So now you tell me, see, now you can understand wherever there is a minor principal point, then this is going to be pole point, right? Yes or no? So here, pole point locates at yes, at a away from, sorry, at a distance of sigma, not distance of sigma, so we cannot use the distance. Away, locates away from origin, yet sigma on negative x-axis. Negative x-axis. Sir, what about the previous thing, sir? Sir, what about this one, sir? You please tell me here. What about this one? The pole point is going to be located here. Pole is located away from origin on positive x-axis. So here pole is located away from origin at negative x-axis. At what is the distance over here from here to here? You please know this is nothing but sigma. So these are some of the conditions I am mentioning you. This is nothing but isotropic condition, and if this is only vertical stress and if there is only these stresses, so this is the way that we have to go through that. Now that's all with the conditions of the pole point I have been discussed. So far I'm telling you, I did not start the failure points. Whatever the discussion I made so far, I just said what is the how the stresses are going to be acting. One is normal stress and other one is the shear stress. So if you look over, there's one more point. Now the note point I want to discuss here is if there is any plane making an angle alpha, and if this is MN plane, and you know this is nothing but the normal stress sigma, and you know this is nothing but the shear stress tau, then definitely there will be a resultant stress making an angle of beta, and this beta is known as angle of obliquity. Beta is known as angle of obliquity. See, I have introduced the three angles: alpha, beta, phi. Alpha, angle made by any plane with respect to the major principal plane, and beta is the angle made by resultant with respect to normal of plane. See, this is going to be the angle. Now you see this is a plane and this is a normal. Sigma is a normal. Sir, how to find out this sigma r, sir? Sigma r is equals to root of sigma square plus tau square. Or in other words, I can write this one. See, observe. This is sigma. And this is going to be sigma r. Here. This value is sigma. This is going to be sigma r. And this value is going to be tau. And what about this angle? Beta. Made by the resultant. So now from this, can I write tan beta is equals to opposite. What is the opposite? Tan beta. Opposite is going to be tau by sigma. So beta is equals to tan inverse of tau by sigma. Keep this in your mind. Keep this in your mind. I am going to discuss it later. So you please observe. This is a resultant. This is the resultant. So now the point is, we have discussed each and every point regarding to the stresses, but still I did not discuss you the failure. What is the definition of a shear strength, please? The definition of a shear strength means ability of a soil to resist the shear failure. Ability of a soil to resist the shear failure. So far we have discussed the concepts. Now, how to use this equation sigma and how to use the Mohr circle, that's where our conditions lies. So the ability of a soil mass to resist shear stress is shear failure, and at a critical condition, the shear stress at a failure is known as a shear strength. See, you know how to determine the shear stress numerically, and you know how to determine the shear stress graphically, and I have proved the graphical and numerical procedures both are going to be same. So I know how to find out the shear stress. Yes. And if this shear stress is going to be the failure shear stress, If this shear stress is going to be the failure shear stress, then we are going to call it as a shear strength, because at a failure, whatever this plane is there or not, whatever the plane, so on this plane, if this shear stress is equals to the shear strength at a failure, so we need to find out the failure theories. Now there comes the topics. Failure theories. So in this, the first theory is again Moore's theory. So according to Moore's theory, what he assumed is soil material eventually fails by shear. Soil material eventually fails by shear. He mentioned that Moore's theory said that soil will definitely fail by shear, and the shear stress at failure is unique function of normal stress. Please go back. This is a Mohr circle. This is a Mohr circle, right? So in the case of the Mohr circle, you observe this is sigma and this is tau, and this tau is dependent on the sigma or not? Array, what is the meaning of graph? X independent, Y dependent. Here Y, tau is dependent on the sigma, where tau means a shear stress, sigma means a normal stress. So whatever the shear stress at failure is a function of the normal stress, and this is what mentioned by the Mohr, and he has given that if this is sigma and if this is a tau, and he mentioned this is going to be the failure line, because just now I tell you shear stress is a function of the normal stress. So what is the meaning of a shear stress is a function of the normal stress, sir? For this normal stress, this is going to be the shear stress at failure. For this normal stress, this is going to be the shear stress at failure. So here these points are known as a sigma comma tau f. What is the meaning of the sigma comma tau f, sir? Failure points. Failure points. Now let me repeat this point again. Whatever the shear stress at failure is a unique function of the normal stress. The more the normal stress you apply, the more the shear stress at failure, which means normal stress increases, shear stress at failure also increases, and Mohr has given this envelope, and this is known as Mohr's envelope. Mohr's envelope, which means locus of failure stresses. Locus of failure stresses. So this is going to be a Mohr's envelope, which is going to be locus of the failure stresses. So what is the failure stress? This is going to be sigma comma tau f. For one particular load, if you apply 50, then I can fail at some stress. If you apply 100, then I can fail at some other stress. Because telling you again and again and again, the more the normal stress, the more the shear stress at failure. Arey sir, I say sir. Now let's remember or recall the consolidation chapter. I hope you remember the consolidation chapter very well. Okay. So I hope like now see the graph is just simply Nana. The graph is like you see this is a function of the normal stress. What is the meaning of this one is? Arre Baba, if normal stress 50, then shear stress would be somewhere 30. Let's assume. Example, for the sake of example, I am telling you, for the sake of example, if I apply a normal stress of 50, then the shear stress is a function of whom? Normal stress. And if I increase to normal stress of 100, then the shear stress at failure would be somewhere 70. So what is the meaning of this one? As the normal stress increases, the shear stress at failure is also going to be increases or not? So now when these are going to be increases, the curve is going to be increases. So the locus of all these failure points, the locus of all these failure points is nothing but the Morse envelope. Still, it's not completed. Wait. But you see, the Morse envelope is going to be linear or curvilinear? The Morse, yes. The Morse envelope is going to be linear or curvilinear? It is going to be curvilinear. Now there comes one person, Coulomb. Coulomb's theory. And he also assumed soil fails by shear. He also assumed soil fails by shear and a linear function exists between normal stress and shear stress at failure. A linear function exists between normal stress and shear stress failure. This is inclusion of more because soil fails by shear as Morse. So, and a linear function exists between the sigma and tau. So, what is the meaning of linear function over here, sir? What is the meaning of linear function, sir? Sir, what is this functions are here? This is a linear or non-linear? This is a non-linear or curvilinear. And now, what we are going to see here is if this is the graph, so in the case of the Coulomb's theory, he mentioned that the function is going to be a linear function. The function is going to be a linear function. So now you see, observe over here, this is a normal stress and this is shear stress at failure. And this function is going to be linear or curvilinear? Curvilinear. And Coulomb assumed, see, these are the assumptions made by the scientists, not by me. And Coulomb assumed that for every soil mass, as I told you, go back. Yes. For every soil mass, soil derives its strength from interlocking between the particles. Interlocking means contact between the particles. Friction means when they move, what is the resistance offered in the tangential direction. You know that soil derives its strength from A, B, C. See, actually frictional resistance also includes the interlocking between the particles. Frictional resistance also includes the interlocking between the particles. So now what we majorly see is friction and cohesion. So now if you observe, in the case of cohesion, the intercept is going to be C. And in the case of the friction, the intercept is going to be phi. As a soil derives its strength from the cohesion. So in the soil mass, already soil has some strength due to cohesion, which means attraction between the molecules. And now if you apply some stress during the shearing, friction is going to be developed. So I told you most of the soil masses will be having a strength of whom? Friction. And fine grains or clays mixed with some other soils has some strength due to friction and cohesion. So now let's go over here. And Coulomb said that, Hare Baba, soil derives its strength from cohesion and friction now. So I have to give some intercept with respect to cohesion. And whatever this y-intercept is given as cohesion intercept. On x-axis sigma, on y-axis tau. And now whatever these points are there, right? For this sigma, this is going to be the failure stress. So sigma comma tau f. For this sigma, this is going to be the failure stress. And on this plane, definitely there is one angle R naught, and this angle is known as phi. Phi means angle of internal friction, and this one we are going to call it as failure envelope, or we can call it as strength envelope. Failure envelope or strength envelope. Failure envelope or strength envelope. You can call anyone this one, where C is known as cohesion intercept, which means due to attraction between particles, and phi is angle of internal friction. Angle of internal friction. So this angle of internal friction due to frictional resistance. Okay. Sir, then sir, you are saying something. What is meant by failure envelope over here, sir? Sir, failure envelope is locus of failure stress points. See, the meaning of locus means a line drawn through the failure points. A line drawn through the failure points. Now, I'll ask you a question over here. So you please say this, everybody. Does this line looks like a straight line having some intercept? Does this line looks like a straight line with some intercept? See, if the line is going to be like this, what is the slope? Y equals to mx. Yes or no? And if the line is going to be having some intercept on the y-axis, so if C is some intercept, then what is the slope? Y is equals to mx plus c. This is the equation of a straight line having some intercept. This is the equation of the straight line without any intercept. So now the equation of failure envelope. The equation of failure envelope. See, I told you this is nothing but the failure stresses are not okay. Y is equals to mx plus c. Fine. Y is equals to mx plus c. What is y over here? What is y? Tau. And the failure envelope represents the failure stress point or not. Failure stress means tau f. Tau f is equals to c plus, and what is m? What is the slope, right? What is the meaning of m? Slope, right? The meaning of m is going to be slope. So what is the slope over here? Tan phi. What is the meaning of slope? Y by x or not? Tan theta is equals to y by x. So slope means y by x, which is going to be tan phi. And what is the meaning of x over here? Sigma. X is sigma into tan phi. And you know that at failure, tau f is nothing but shear strength. So what is the definition I have given here? This is a shear strength S. In the previous chapter, I took S as settlement. Now in this chapter, I am taking S as a shear strength. So now you tell me, what is the shear strength? S is equals to C plus sigma into tan phi. And this is the equation of a shear strength. So now I hope you understood what is the meaning of this equation. Have we used this equation somewhere in chapter number 8? While I was deriving while I was defining the piping failure, Moore envelope and failure envelope both are same only. See, Moore's envelope is also failure envelope only. This is also failure envelope. This is also failure envelope. But this was given by the Moore and this was given by the Coulomb. So this is Coulomb's. Coulomb, generally we call it as a Moore Coulomb failure envelope. We call it as generally Coulomb's failure envelope. So now generally, because as Coulomb has taken care of the Moore also into the account, so we call it as a Moore Coulomb. In some textbooks they give us Moore Coulomb also, so don't worry about that. So now that's about the conditions. Wait. Yeah, yes. Okay, so now let's see. Yeah, very good questions asked by the people. So far and so good. Throughout this chapter, I did not mention anything regarding to the effective stress. Did I? See, in the earlier chapters, I told you total stress and effective stress. Yes or no? But in this chapter, so far, did I mention anything regarding to the effective stress? No. And if you remember the effective stress chapter, the effective stress chapter is given by whom? Carl Terzaghi. And Terzaghi is the father of soil mechanics because he introduced the effective stress concept. Yes or no? So now there comes Baba. Whatever the C and phi, I am representing over here, this C and phi, so far I did not discuss anything regarding to water. Did I? You go through the any slide, did I discuss anything regarding to the water? Nothing. I just made some analysis. If this is a soil and if there are the outer stresses, then how to determine the stresses. That's it. So now the node point over here is C comma phi are shear strength parameters. Parameters only. They are not properties of soil. They are not properties of the soil. They depend on type of test and mind it what I am going to write this one, drainage condition. Sir, what is the meaning of drainage, sir? Water table, sir. Whenever the water table comes into the existence, now there comes the drainage condition. So the point of this one is this C comma phi are not inherent properties. Inherent means constant properties. They depends upon the drainage condition. Sir, what is the meaning of this one, sir? Now I am asking you, sir. Sir, you are on a floor, okay? On a dry floor. You are on a dry floor. When you walk over a dry floor, the friction between your foot, means you, and the floor is different. Yes or no? Now, pour some water on the dry floor. Means now I am taking the wet floor. And while you are walking on the wet floor, the friction between you and the wet floor and the friction between you and the dry floor, does both are same? Tell me, you, the person, same, the floor, same thing. But what I have done, Earlier I took dry floor and then I took the wet floor. And in both the conditions, do you think the friction is going to be same? No, because when water comes into the existence, everything is going to be changes. As long as you take dry state, friction is same. Or as long as you go only the wet state, friction is same. But when you go from dry to wet or wet to dry, the friction changes. Between the particles, there must be some friction, right? Between the particles, there must be some friction. If you add some water, then the friction would be less, then the particles will slide off easily. Friction would be less, the particles will slide off easily. So the C comma phi are not a inherent properties. They depends upon the type of test you are doing, and it depends upon the drainage condition. So now, based upon this point, yes, cohesion also depends upon type of soil, sir. Yes, that's the reason why I am saying see, cohesion intercept. Type of soil is different, and in a soil, the drainage condition is different. See, gravel and sand is different. Gravel and sand is different. Yes or no? But in the case of sand, coarse sand and fine sand both are same. Saturated sand and dry sand both are same. You tell me now. How somebody is asking, sir, how phi is based upon the drainage, sir? Are sir, saturated sand or dry sand, sir? Dry sand ka friction zyada hai, sir, because no water. But in the case of the saturated sand, sorry, dry sand, in the case of the saturated sand, due to water, the friction between the particles is less. Just imagine yourself walking on a dry floor. Imagine yourself walking on a wet floor. If you feel the friction the same, then don't ask me the question. But if you don't feel the friction the same, this is the point. Yes. So now, let's come to the next one. So with this, now Coulomb's comes in. First of all, who came? Moore came, and Moore said this failure envelope is going to be curved. And Coulomb came. Are Baba, Coulomb came, and Coulomb said, Are Baba, Moore, you took the curve as a curvilinear. If it is a curvilinear, I cannot do any analysis. So what I take is the linear functionality. Then from the linear functionality, I got this equation. And from at the end of the Coulomb, what I am saying, the C comma phi are not depends upon the soil mass, they are depends upon the drainage conditions. Now, this condition was taken by whom? Our father, Terzaghi. The third one, Terzaghi's theory. Terzaghi's theory. So now this is based on effective stress condition, which means drainage conditions are included. So drainage conditions are included. Then S is equals to C dash plus sigma dash into tan phi dash. So this is the equation where C dash is effective cohesion intercept, phi dash means effective angle of internal friction. Effective angle of internal friction. Sir, now you can ask me one more question. Sir, you are saying one equation over here. You are saying one more equation over here. This is based on the total stress. This is based on the total stress. And this is based on the effective stress. See, this is based on total stress. And now this is based upon the effective stress. So now you can ask me a question, sir, when to use which equation, sir? Which means when to use the total stress, when to use the effective stress. So for that, I am going to discuss about based on the drainage conditions. So now, based on drainage condition, based upon the drainage condition, I am going to include if there is no drainage, undrained condition. If there is a drained condition. So now come on, you please look over. Everybody listen to the point what I'm going to say here. What is meant by undrained? In consolidation chapter, let's recall some topics from the consolidation chapter. I hope you remember the consolidation. What is meant by consolidation? What is meant by consolidation? Process of expulsion of water. That's it. And you know that when an external load is applied on a soil mass, if I'm soil, when an external load is applied on a soil, immediately the entire external pressure will be taken by water and it develops as excess pore water pressure. I hope you remember that point. So when an external load is applied on a fully saturated soil mass, immediately entire external pressure develops as excess pore water pressure U bar. Now during the consolidation, what is the meaning of during consolidation? Pore water should dissipate or not? Or how the pore water is going to be dissipate or expel? If there is a drainage, then only there is a expulsion of water. For example, I am not providing any drainage. If I am not providing any drainage, now you tell me please, if I don't provide any drainage, is there any expulsion of water? Think and say. See, drainage means if the clay layer, see, let's say I'm going to provide this is clay and this is a sand and this is a sand. This is nothing but drainage layer or not? So I can say this is a double drainage. This is going to be double drainage. Yes. Now, in the same case, instead of this one, if I provide a rock, then this is going to be single drainage. Yes or no? Then the water will dissipate only in a yeah. So then the water will dissipate only in the case of the vertical layer. Sir, then what is the meaning of the no drainage, sir? Sir, the meaning of no drainage is if this is a clay and above there is a rock and below there is a rock and rock. Now you tell me, do you think the water will dissipate above or below? No. So if there is no dissipation, means if there is no drainage, then yes. Okay. So if there is no drainage, then there is no dissipation of water. When there is no expulsion of water, do you think consolidation occurs? No. Consolidation meaning itself is expulsion of water. No drainage, no consolidation. And when there is no consolidation, do you think the effective stress comes into existence? So you please go through the previous points. I can show you if there is a possibility. I don't think they are here. Okay, they're not here. But I hope you remember. But I hope you remember. You know that during consolidation, as a pore water dissipates, excess pressure decreases. When the excess pore water pressure decreases, then only effective stress comes into existence. Yes or no? Yes. If there is no drainage at all, when there is no drainage, then there is no dissipation. When there is no dryness, then there is no dissipation. When there is no dissipation, if there is no change in the pore water pressure, how come the effective stress comes into the existence? I am a soil mass. You apply load and entire pressure will be taken by whom? Water. If the water goes out, then the solids will take the pressure. But as there is no dissipation, no consolidation, no reduction in the excess pore water pressure, and the change in effective stress is zero, which means no effective stress. So when there is no effective stress, then you have to consider whom? Total stress. So in the case of the undrained condition, no dissipation of pore water. When there is no dissipation of the pore water, U bar is not equals to 0. What is the meaning of U bar? What is the meaning of U bar? Excess pore water pressure is not equals to 0. And delta sigma dash is equals to 0. So when there is no dissipation, no change in the excess pore water pressure, and effective stress becomes 0. And here drained condition, complete dissipation of pore water, which means U bar is equals to 0, then delta sigma dash is going to be greater than 0. So in such type of conditions, in this case, total stress analysis, and in this case, effective stress analysis. This is total stress analysis, sir. Why I am taking the total stress analysis, sir? Because you see, sir, effective stress is going to be 0. And in the case of the drained condition, there is effective stress. So here you are going to take it as effective stress analysis. So here we are going to take it as effective stress analysis. Sir, now I hope you understood when to use total stress. In the case of the undrained condition, use the total stress. When to use effective stress, in the case of the drained condition, you use the effective stress. So now from this, I can write the equation S is equals to C plus sigma into tan phi, and here S is equals to C dash plus sigma dash into tan phi dash. For easy understanding, what I do is, I provide this is going to be Cu and this is going to be phi u. Sir, what is the meaning of U, sir? The meaning of U, sir, means undrained, sir. No drainage, sir. So from now onwards, my dear students, please remember, if there is no drainage, no pore water dissipation, no effective stress, you have to use total stress. And when is a total stress, then C becomes a Cu, phi becomes phi u. Cu comma phi u are undrained parameters, whereas C dash comma phi dash are drained parameters. So that's what I want to discuss. So this is very, 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 very important. Is going to be so. Now I hope you understood based on the drainage conditions when to use the total stress and when to use the effective stress. So tomorrow holiday or day after tomorrow holiday. Tomorrow is a holiday. Tomorrow is a Sunday. As I told you. So yes, U bar not equals 0 means 100% load taken by U bar only. There are a lot of topics in this chapter. This chapter is not going to be end with a small. So not holiday on Ramjan. I'm sorry for that. But my dear Muslim students, I'm sorry for saying that because I have to keep everyone in your mind. So even I have asked the IAS team. So what they said is, so you have to give a break on Sundays only, not on the Monday. So tomorrow is a holiday. Not Monday is a regular holiday. Sunday is a regular holiday. Sir, human brains, wow, my dear student, sir, human brains destroy, sir, due to continuous usage of mobile and gets radiation, sir. Again, we have plenty of life. We have not seen anything and not written gate also. Are kahare bhai aap? So, okay, with the 2 months of the COVID itself, you start to thinking about the radiation and you start to thinking about plenty of life itself. Yes. And what about the previous years? I hope you might be in BTech third year or final year. So definitely by that time, means your age people would get the mobile phone from the first year and second year. And I hope you must have, if you are a boy, you must have flirted with a lot of girls. And if you are a girl, you have got a lot of messages from the boys also. So vice versa will be happen, which means there is a possibility that you have used Instagram, Facebook, WhatsApp rigorously and vigorously. By the time your phone gets heat also, you don't give and you don't show some kindness towards your phone and you used it continuously, so as your 100% battery becomes to 0 and then the 0 to 100%, vice versa. In a day you're going to keep charging for 24 hours in 24 times. And now you're speaking, sorry, if I use phone, there is a radiation. Yes, faltu. So then what we do on festivals? So do we need to attend? I'm sorry, my dear, please, you have to attend. Actually, I don't have a plan to give a holiday tomorrow also. So I want to take the classes continuously, but so higher authority is higher authority for everyone, right? So I have to follow that. Okay, fine. Okay, okay, fine. As see, give me 1 minute. I'll make sure. So I'll call to my team, a technical team, and I'll let them to know whether I have to give holiday tomorrow or not. So give me 1 minute of time. I'll get back to you because so they have to means the celebration and mind it, my dear friends. I mean, I'm saying the Muslim friends. So just because of it is a Ramjan, Eid. Do not go into a public areas as a mass crowd. So I'm not against any religion over here, but I'm saying you the precautionary fact that we need to go for the COVID. So I hope you people will try to stay in your home and spend a good time with your family and eat whatever the food you want because you have been fasting from the past 1 month or so. You eat very good food and you spend with your family, but give me some time, 1 minute. I'll call to them and I'll let you know. So, yes, my dear friends, tomorrow it's not a holiday. Tomorrow there will be a class and Monday will be the holiday. So the holiday is on Monday, not tomorrow. Don't think Sunday is a holiday. So Sunday is also working day for you and Monday is a holiday. Monday is a holiday. So now, okay, fine. So with this, it's already 12:54 and I don't want to continue further because if I do continue, it will take time. So what I do is, see, today the shear strength topics I have been taken. The shear strength topics are, so the basics of the shear strength I have taken. And you please go through all these basics because these basics are very, very important. See, still I have added the parts. I told you two parts, but I have not attached the two parts. I have explained you the Mohr circle. You see, I have explained you the Mohr circle and I have explained you the failure and loop. But I did not give you what is the relation between the Mohr circle and failure and loop yet. So brace yourself. We are going to discuss that thing tomorrow. But by the time, you please go through the notes and you look over the notes once again. And tomorrow there is no holiday. Tomorrow is a class. So that we can continue, means some continuity and momentum would be there. So tomorrow we'll be discussing the remaining topics. As of now, I am closing today's session and I'll be taking the doubt clearing session now. So the people who wants to leave, they can leave. Yes. Now, how could someone put class on Sunday? Disgusting. Oh my God, you got disgust. And because of this comment, I got embarrassed. I'm sorry for that, but you have to be. So I'm closing the session and I'll be taking the doubt clearing session. And one more time, so people who has not given the feedback, you please open that link again. So I said to the higher authorities, means a technical team. So they said that they will look into that. Okay, fine. So now I'm going to enable the option so that I'll spend some time with the students. A doubt clearing session. So come on, please. So Mr. Vinay.
Hello, sir. Good afternoon, sir.
Good afternoon, Vinay.
Sir, in an undrained condition, there is no presence of pore water, sir.
Yes.
In undrained condition, there is no
Yes.
presence of pore water, sir.
Yes. No, not no presence, no dissipation. In the case,
There is no.
see, the drainage is going to be there when there is a water table. Yes or no?
Yes, sir.
What is the meaning of undrained? No drainage is provided. No drainage means you are not providing anything to allow the water to go out.
Okay, sir. It is a
Example,
constraint.
let me tell you one thing. For example, you have a water tank. Okay, means normal water tank, small water tank. So in a home, we can keep that drinking water tank, and there is a small tap for the tank or not. Yes.
Yes, sir.
If you open the tap, then only water will go out. Yes or no? Yes or no?
Yes, sir.
Yeah. So in the case of undrained means I don't open the tap. Undrained, I'm not opening the tap. If you don't open the tap, does pore water will go out?
No, sir.
When the pore water will not go out, then excess pressure would be there. And what about effective stress? Zero. You please go through the consultation 3 points over there. I told you there. When the excess pressure decreases, then only effective stress will increases. Yes or no?
That's why there is no change in effective stress, sir.
Yes. No change in the effective stress. So we have to go for that total stress analysis. Yeah. Okay, fine.
Sir?
Yeah, tell me.
Sir, if there is no dissipation of water, there is excess pressure of pore water, sir.
Huh?
The pore water pressure will increase, no, sir. There is no dissipation.
Yes.
Is there any harm
Not going
to
to be increased. Pore water pressure depends upon the load. Okay. For example, if you apply 50 kilopascals, right? Yes. Initially, the entire 50 will be developed as U bar or not?
Yes, sir.
Yes or no?
Yes, sir.
Yeah. So if there is no dissipation, that 50 will be there completely. Throughout the soil, the 50 will be as a excess pore water pressure only. If you allow the water to go out, then the excess pressure decreases, effective stress increases.
Yes, sir.
Okay.
Sir, is there any side effect due to excess pore water, sir?
That you will see later. See, it's now we did not consider the entire things, right? We will see later.
Okay, sir. Thank you, sir.
Yeah. Okay, fine. Bye. Mr. Mahendra. Mr. Mahendra. Mr. Mahendra, no. Sir, whatever you are teaching, does it include at least some portion of ESC mains? See, I'm including almost all the topics ESE mains. In the ESE mains, I'm missing 10%. 10 to 15% of topics I'm missing over here in mains, not for the prelims. So that 10 to 15% only exclusively for the ESE and that too for the mains, we will be discussing later. Next, Mr. Sai Krishna Aditya. Mr. Aditya.
Hello.
Aditya.
Hello, sir.
Yeah, tell me.
Sir, I'm audible, sir.
Yeah, you are audible to me. Come on, please tell me.
Sir, I have doubt in previous gate question, sir.
Which question?
In consolidation chapter, question number 19, sir. 2 marks.
Let me check that. Consolidation chapter.
Question number 19, sir.
Two marks.
Yes, sir. Elastic settlement question.
Yeah, what happened?
Sir, in that question, IF is not given, sir.
Huh?
Influence value is not given, sir.
A circular raft foundation of 20-meter diameter and 1.6 meters is given for the okay bearing pressure of 110. Young's modulus, Poisson's ratio they have given. The raft is made of concrete. So this is a concrete. Consider the raft as rigid. The elastic settlement. Okay, let me check that once. Have a detailed solution.
In this question, EC and Poisson's ratio are given for of concrete are given for confusion only, no, sir?
For confusion only, for to make you to feel confused only. That's just a tactic. That's it.
Yes, sir. We have to use for what is for soil. That only we have to use.
Yeah, yes. See, actually, it's a circular footing, right? See, actually, there are some values for the footings. I'll be sharing it to you.
Okay.
For circle, I value for flexible is going to be 1.
Means for rigid it will be 0.8.
For rigid, it is going to be 1 into 0.8. The value is going to be 0.8. Actually, see, this is for circle. This is for circle. The flexible value is going to be 1. Actually, I forgot to share that value.
Yes, sir.
So yes, I will be included that.
And sir, in this question, B will be the diameter, no, sir?
What?
B will be the diameter. Yes. Sir, in previous IES, sir, I have one doubt, sir.
Chapter?
11th chapter, sir, 53rd question.
Yeah, what happened?
Sir, in this first statement, sir, it is correct, sir. Second statement, sir, I'm not understanding.
That soil always remain in normally consolidated position. Yes.
Means, sir, it is a correct explanation, sir.
Yes, that is a correct explanation. That's the reason why. See, when we go for the normally consolidated, then the
Yes,
is going to be a compression curve. It won't be a recompression curve. Okay.
Yes, sir.
So that's the reason why at first we try to maintain the soil should be a normally consolidated.
Sir, but it should not be double, no, sir. Even if it's increased by some amount, then also it will be a compression curve only, no, sir.
No, for maintaining the uniformity.
Okay, sir. But sir, in answer they have given B, sir, for this.
Okay, for maintaining the uniformity, it is intended that the soil always remain a normally consolidated condition. A soil will be always try to maintain a normally consolidated condition, but as you said, sir, it need not to be doubled. It can be one time more also, but the double condition is for the uniform condition. Okay.
Okay, sir.
To make the uniformity, we make double, but apart from the double, if you increase 0.5 times also, that is going to be normally consolidated only.
Yes, sir. Answer will be B,
Both
sir.
are correct. Both are correct, but not correct explanation.
Okay, sir. Thank you.
Yeah. Sir, will the AS material will be sufficient to get top 10 rank in the GATE? If not, please suggest to me any good book to practice more number of questions. And Mr. Shashidhar, actually, see, what my suggestion is, you please follow the first material. Means volume 1, volume 2, GATE practice questions, ESA practice questions, classroom practice questions. So, and you go through the test series. And if you still have a time, I'm telling you, if you still have a time, then you open the textbooks. If you go through the Gopal Ranjan textbook, Gopal Ranjan, that is a very, very good book. And then Venkatramaya, you solve the practice problems at the end. So these two textbooks are, you solve the Gopal Ranjan. And if you have one more, means I'm giving you, I have one more book with me. What is that book? So this is one more book. I hope you can see this one. This is Soil Mechanics and Foundation Engineering by Purushottam Raj. This is also one more book. And I'll suggest you. So I have some objective book also, but it's not with me. But yeah, yes, I'll tell you in the tomorrow class. I have some objective books also. You can follow those books. And mind it, it's all if you get a time. Then only. Yeah, Punya also good. Sir, why R is 0 at below the point load? Sir, below the point load, the loading point and the point where you need to find both are same, sir. When the loading point and point both are same, then there is no distance between these two. You here, me here, then the difference, the distance is there. And if you and me both are at the same point, then what is the distance between you and me? Nothing. So what is the Proctor's plasticity needle? The Proctor's plasticity needle is to check whether the compaction is good or not. It's just like how we check the bitumen grade of bitumen. So now let's see some other people. Mr. CVR.ac.in.
Sir,
Tomorrow is not a holiday. Yeah, come on.
to 50 questions.
Yes, which chapter?
Classroom practice questions, permeability 50 questions.
Yeah, tell me. What happened?
The directly proportional for we have for void ratio and for viscous to have both on the kinetic relation there, sir.
A directly proportional to E cubed by 1 plus C into 1.
Case inversely proportional viscous.
Yes. I have seen this the equation only now from the laminar flow equation only. I have made this one.
Yeah, answer our
Answer will come, yeah. Answer will come. You see, K2 by K1 is equals to E2 by E1 whole cube into 1 plus E1 by 1 plus E2 into mu1 by mu2. Yes. So you please find out for N1, what is N1 over here given? 40%. You please find out E1 for N2, 35%. You please find out E2. And they have given viscosity at 25 degrees is 0.9 times of viscosity at 20 degrees, which means mu1 is going to be 0.9 times of mu2 because the earlier test was done at what temperature? 25 degrees. And now the test is going to be 20. So that's the reason why mu1 is equals to 0.9 mu2. And you got K1 value, you can substitute, you can get the answer. Okay, answer is going to be 0.9 something. I didn't remember.
Thank you, sir.
Okay, you please substitute that. You might have done something wrong while calculation, but you can get it done. So fine. Will ACE cover general studies topic for IAS paper 1? Yes, it will cover. So is consolidation is a function of effective stress or pore water pressure? It's a function of effective stress, but that will come once the excess pore pressure dissipates only. So now let's see. Mr. Pawan Kalyan.
Hello, sir.
Yeah, Pawan, tell me.
Sir, in the previous CSC consolidation chapter, sir. Hello.
Yeah, tell me.
38th question, sir.
Yeah, tell me what happened.
Sir, in that the plasticity index is same for both, sir. But how can we say which one is more plastic?
Depends upon the compressibility also, right?
Yes, sir.
Which one has more liquid limit, that will be having more plasticity.
But option is given as C, sir.
What is the answer there? First, let me see the question once again.
Okay.
Liquid limit, plastic limit. So for X and Y, they have mentioned, and the natural water content. Which of the clays X or Y experience largest settlement under identical loads? So is more plastic and is softer in the consistency. So larger settlements. So as you know that whatever the SF is going to be directly proportional to CC.
Yes, sir.
So CC depends upon the liquid limit. Whatever the liquid limit, they're having whichever having a liquid limit, that will be having more plasticity. I mean more compressibility.
Yes, sir.
So Y and softer in consistency means IC.
Consistency index.
Yeah, consistency index IC should be less, and
Yes, sir.
directly over here. So yeah, the Y has a consistency less index. Yes.
Yes, sir.
Because as water content is very near to the liquid limit, so Y, and so this is Y. Okay, fine. Larger settlement Y, and softer content also Y. And now coming to the more plastic. So according to this one, what they mentioned is, you see this plastic state. What is the plastic state over here? 22, and here also 22. Yes, but where is the natural water content is locating?
30.
Let me check. More plastic. Happy value only. Yes, fine. Okay, the answer should be actually Y only. So let me check once. Yes, Pavan.
Sir.
Yeah, I hope you are listening. Actually, see, from the given options, they mentioned that answer. See, because we know clearly this one and this one, right? Actually,
Sir.
and this is correct. Yes.
Yes, sir. Yes, sir.
And we have any other options which is focusing the remaining? No. Then
Okay.
it as X. Actually, the correct answers are going to be Y only.
Okay, sir.
Y only. But we know larger settlement is Y. Softer consistency is also going to be Y. From the given options, there is no reliable answer. Yes or no?
Okay, sir. Yes, sir.
That's the reason why they took C. Answer is going to be C.
Okay, sir. And then question number 50.
Yeah.
Question number 50, sir.
Question number 50. 50.
Yes, sir.
Just tell me.
In the second statement, if the compressibility of field deposit is more, means then relative compaction will be more than 100%. No, sir.
The compressibility of field deposit is slightly greater than shown by a laboratory. Compressibility is different and compaction is different. Pawan. Compressibility is it's just a compression of a soil mass. Okay. See,
Sir.
the compressibility of field deposit is slightly greater than the shown by laboratory sample. Means in lab we take small sample, right?
Yes, sir.
But in the field, the soil is going to be large. It's going to be infinite, semi-infinite, na? So
Yes, sir. Yes, sir.
whatever the compression we get in laboratory, it's different, and field is going to be different. Field will have a little bit more. Compaction is different. Compaction is application of the load. That's it. That is different. Okay.
Okay.
You are not going to discuss about the settlements. Yes.
Okay, sir. And the third statement, what are those terms, sir? Like hydrodynamic lag, plastic lag.
Hydrodynamic lag means due to excess pore water pressure. Lag means settlement. Okay.
Okay.
So in Terzagh's theory of one-dimensional consolidation, only hydrodynamic lag is considered. Plastic lag means due to the particle size distribution are there or not. At the last,
Okay. Yes, sir. Yes, sir. Secondary consolidation.
as plastic lag. So we know that in Terzaghi we consider only primary consolidation, right?
Yes, sir. Yes, sir.
Primary consolidation means hydrodynamic lag.
Okay. Okay.
Yeah. Okay. Fine.
Sir, one last doubt, sir.
Yeah. Tell me.
Regarding bulking of sand, it occurs due to capillarity, no, sir.
Yes.
But due to capillarity, effective stress increases, no.
Yes.
But effective stress increase means particle will come closer, so the density should increase, right?
Very good question. See, that is before compaction or after compaction?
Which one, sir?
Whatever you said, the point is before compaction only, na?
Yes, sir. Yes, sir.
Due to effective stress, already particles are closed, right?
Yes, sir.
Now, what happens is if you compact, do you think the particles will close further?
No.
So then if I add more water up to 4.5%, if I add more water, then the capillary film will be there or not at
Yes,
the
sir.
surface. That will get breakdown. And if they
Okay.
break down, then the particles can become much closer. Okay.
Okay. Okay. Okay, sir.
Yeah.
Okay. Thank you, sir.
Yeah. Next, Mr. Shubham, speak out.
Hello, sir.
Yeah.
Sir, in consolidation chapter, previous gate question number 9 and 10, sir.
Consolidation chapter.
Yeah, previous gate questions.
Yeah. Previous gate consolidation chapter 9 and 10.
Yes, sir.
Yeah, tell me. The
Sir,
average,
here I'm not able to find it.
no, the average effective overburden pressure on 10 meters thick homogeneous saturated clay layer is 150. The average means at center. At the center of the clay layer, the
Yes,
average
sir.
effective is 150. Okay. Consolidation test on an undisturbed
Yes, sir.
soil sample taken from the clay layer shown that void ratio. See, from this specimen, so they said that by taking the consolidation test, the void ratio decreased from 0.6 to 0.5 by increasing the stress from 100 to 300.
Yes, sir.
Okay, by increasing the stress from 100
Yes,
to,
sir.
and that's also good. Then what's the question?
Yeah.
Then?
Initial void ratio and settlement.
The initial void ratio and the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity. So first of all, you need to find out the CC Nana from the given data.
Yes, sir. We can find it.
From the given data, you can find out the CC. And you can use it to delta H by H is equals to delta E by 1 plus C. Or
Yes.
you know, let's see, I'll write over here. You see. Okay. Now, in the consolidation test, if the stress is going to be 100, what is the void ratio? 0.6. Yes.
Yes, sir.
If the stress is going to be 300,